Wait to see if it's streaming. I'm gonna do the same thing that I did yesterday. I think it was yesterday. Which is use ChatGPT to study these topics here. I'm gonna start with HTML, CSS. Then I'm gonna go to Git and then C#. And I wanna try to finish all of them at some point. Probably not today because there's too many, but I also have to work on the next video. I finished the editing for the previous one. I did the whole highlighting thing, but then the GPU wasn't strong enough, so I had to redo everything. And I had to make a new video, a new clip explaining what was going on and put that in the end. And that's why it took me a lot of time to do that. And I finished that today, actually. So now the next video is going to be about functions. So I also have to work on that. So I'm not sure how I'm going to make it so that I do this stuff here, and then I'm not sure I'm going to split it. Do this stuff here and also work on the video. But I think I'm going to work on the video tomorrow. And today I'm going to try to spend more time here. I'm going to put 1 hour and a half. Then I'm going to probably... Yeah, I'm gonna take a break, meditate, I think, and then go back and then do probably half an hour or something like that, then go eat, and then go back to 1 hour and a half breaks.
To ensure that data you store using the web storage API is cleared when the user...
Yeah, these questions here are from this one. I already did them, so I'm just gonna put the questions here on the ChatGPT thing and then use text-to-speech, listen to them. And I'm probably not gonna talk much because I wanna stay for longer and get more topics done.
To ensure that data you store using the web storage API is cleared when the user closes the browser, you can listen for the before unload event. This event is triggered just before the browser window is closed, giving you an opportunity to perform any necessary cleanup. For example, you could add an event listener for the before unload event and use it to clear the web storage data when the user closes the browser. Window.addEventListener, before unload, function, // clear the web storage data here. Keep in mind that the before unload event is not guaranteed to be triggered in all cases, such as when the user simply navigates away from the page without closing the browser. Therefore, it's important to not rely on this event as the sole mechanism for clearing web storage data. Instead, you should also provide an explicit way for the user to clear the data, such as through a button or link on the page. Additionally, note that the web storage API is intended for storing data that is specific to a particular site or application. If you want to store data that will be shared across multiple sites or applications, you may want to consider using a more robust solution, such as IndexedDB or a server-side database. The downloading event is fired by the app cache object when the cache download is started. The progress event is fired periodically to provide updates on the download progress, and the cached event is fired when the download is complete and the cache is ready to be used. Here is an example of how you could listen for these events and use them to update the user on the status of the cache download. var app cache equals window.application cache, app cache.addEventListener, downloading, function, console.log, cache download started, app cache.addEventListener, progress. Function, console.log, cache download progress, plus e.loaded plus of plus e.total, app cache.addEventListener, cached, function, console.log, cache download complete. Keep in mind that the app cache API is being deprecated and should no longer be used for new development. Instead, you should consider using other technologies, such as service workers, for caching and offline support. The type attribute of the input element can be set to tell to define a control for entering a telephone number. This will cause the browser to render a text field with a specialized keyboard layout that is optimized for entering telephone numbers. Here is an example of how you might use the tell input type. When the user focuses on the input field, the browser will display a keyboard layout that includes keys for entering digits, plus a few special characters that are commonly used in phone numbers, such as plus, dash, and. Keep in mind that the tell input type is not supported by all browsers, and some older browsers may simply render a regular text field instead. Additionally, the appearance of the input field and keyboard may vary depending on the user's browser and operating system. A valid section of an app cache manifest must begin with the cache or network keyword, followed by a colon, smiley face, followed by a list of one or more URLs or path patterns, each separated by a space. For example, the following is a valid section of an app cache manifest. Cache, /index.html/styles/main.css/scripts/main.js. This section specifies that the index.html, main.css, and main.js files should be cached by the app cache. On the other...
I also received some feedback on the videos that I'm making for the other channel. And people said that I should make something like an introduction or something like that to tell people what is the point of learning JavaScript and Python. And at first I didn't get it. Actually, it's not that I didn't get it, it's that the reason why I'm making the videos is coming from the place where I want to teach people in the way that I wish someone taught me when I was starting, which is more straight to the point and just try to cut the bullshit as much as possible. So pretty much just try to extract everything that is useless and just focus on the stuff that is essential and that I use most of the time, or that it seems to be the most important. And obviously I could be wrong about that because I don't have a lot of experience, so that this might change in the future. But then after this feedback, I realized that someone that it is starting out, like I was back then, I was also like that, but I didn't remember, which is you don't know anything about how the internet works and how everything communicates with each other. And I also remember being lost about that because at the beginning, I didn't understand how the code becomes the web page and how everything connects. And I didn't want to make the first videos about that because then that's a very big topic, and then I have to talk about a bunch of different things, and I'm gonna have to study and everything like that. That's the reason why I decided to do the Python and JavaScript videos first. But it is a good point that someone that is starting out doesn't have that understanding. So, but then the problem is, the issue is that how do I explain? Because I'm looking at it more from a standpoint of a series. So that's roughly what I tried to do in the first video, which is to explain for people what are the things that they should study or they should keep in mind in the beginning, because they don't know what they don't know. And that was the place I was coming from for making that first video. But then the problem with that is that on the other videos, someone might watch the 6th video or 5th video first, and then they have no context. But to me, it was kind of like clear that if I put number 5 on the title, people are gonna know that it's from a playlist, and they're gonna watch the first video. But I think most people, they don't think like that, because that's the way I think and the way that I think I would perceive that. But maybe it's not even true for me. So I think that the middle approach, it might make sense to make an introduction for every single video and try to keep it as small as possible. And I don't want to make a unique introduction for each one, because that's just, it takes too much time and it doesn't feel like it's necessary. But I do think that I should make probably an introduction and then just briefly talk about it as fast as I can, about what are the applications of JavaScript, explain that JavaScript runs everything on the internet pretty much, that every application, every site that you see on the internet through the browser is gonna have JavaScript, is gonna be built with JavaScript, and that Python is used for automation, creating bots, and data analysis, machine learning, and extracting data from the internet. So I should talk about this in the beginning of each video. So I'm thinking about making a small video of introduction, and just briefly talking about the applications of Python, JavaScript, and putting that in the beginning of every video. But I still haven't decided if I'm gonna take off all the videos that I have now on the site and then add the introduction and re-upload them, or if I just leave it the way that it is, and then only on the new videos I add the introduction. I think I'm gonna end up doing the second thing, which is just adding the introduction for the newer videos, because the ones that I uploaded, they don't have a lot of views, but they still have some views. And I don't know, yeah, but maybe it is a mistake because these videos are gonna stay there for a long time, so I still haven't decided about that. But in order to do that video, I think I'm gonna do a little bit of research. So I might do that tomorrow if I stream, which is very likely that I will do. I'll stream for 1.5 hours, but I still wanna study this stuff here as well. So maybe I will structure because I think the next video is gonna be about functions. And I'm not gonna go in depth in the next video about functions because I'm just explaining functions to be able to explain methods later. So hopefully it's gonna be very fast to create the setup for the functions video. So I think that's what I'm gonna do tomorrow, is create the setup for the functions video, and then right after that do the research for the introduction video, then stop streaming and then record the introduction, and then maybe come back to study the continue to study with ChatGPT.
On the other hand, the following is not a valid section of an app cache manifest. myapp/index.html/styles/main.css/scripts/main.js. In this case, the section begins with the myapp keyword, which is not a valid app cache keyword. As a result, the app cache will not be able to parse this section of the manifest, and an error may be thrown. It's important to make sure that your app cache manifest is correctly formatted and includes only valid sections, in order to avoid errors and ensure that your web app can be cached correctly. An iframe is an HTML element that allows you to embed another HTML document within the current document. By default, an iframe will load content from the specified URL, which can be on a different domain than the containing document. If you want to load content from the containing HTML document into the iframe, you can use the srcdoc attribute instead of the src attribute. The srcdoc attribute specifies the HTML content to display in the iframe, and it will override any content loaded from the src attribute. Here is an example of how you might use the srcdoc attribute to load content from the containing document into an iframe. In this example, the iframe will display the specified paragraph of text, rather than loading content from a URL. Keep in mind that the srcdoc attribute is not supported by all browsers, so you may want to provide a fallback solution for older browsers that do not support it. For example, you could include the content to display in the iframe as the inner HTML of a div element, and then use JavaScript to move the div into the iframe when the srcdoc attribute is not supported. To designate a page as available offline, you need to create an app cache manifest for the page. An app cache manifest is a simple text file that lists the resources that should be cached by the browser, so that they can be accessed even when the user is offline. To create an app cache manifest, you first need to create a text file with the .appcache file extension. This file should include a cache section that lists the URLs of the resources that should be cached, such as the page itself, any associated CSS or JavaScript files, and any images or other media. Here is an example of a simple app cache manifest that specifies a single page and its associated resources. cache/index.html/
I think I lost some context about how does it feel to be a beginner. This feedback showed me that, and it's a good and bad thing at the same time, because it's good because it means that I'm learning a lot, and what I know right now is very, very different than when I was starting, because that comment made me remember one of the streams that I was doing, and then someone entered in the chat and they were helping me with some stuff and I have just a bunch of different questions and how everything connects and how everything works. And now after watching all of these videos, doing all this studying and building a bunch of things, like my mind is a lot more clear about how everything is connected in the internet. And I just took that for granted when I was doing these videos. So yeah. And someone that is new is gonna be at the same place that I was when I didn't know anything, and they're not gonna understand that JavaScript is used to build the actual websites. They're not gonna have the connection in their mind. So I have to think about what is the most efficient way that I can do right now, or that I can explain. I don't think, obviously I'm not gonna go through the details. I'm just gonna try to do something as fast as possible so that it doesn't get too long, because I'm gonna do that on each video. The other thing that is the problem with this is that I was thinking about, I didn't want to do any introduction, because I notice when I'm watching playlists on other channels, it's really annoying when the person has an introduction or something like that, because especially if it's not that big, in both cases it's bad. If it's big, you're just gonna skip, but if it's small, it's in a way even worse, because you can't skip, and because it's the same introduction, is just this annoying little thing, especially if they have short videos that you keep listening all the time and is completely useless. And that's why I didn't want to have any introductions like that. But I think for these videos, I think it's better to do it, because it's for beginners. But then, yeah, that's the thing that I'm not sure about, because there's two different ways to look at it. One way is to look at it as a playlist, as a series, and then it makes sense that I explained everything in the first video, because then it means I already explained that. So if people don't know, they're gonna watch the first video. Like if they got that was the way that I was thinking. If they got into the fifth video already, and they don't understand what's going on, they're just gonna see that it's the five video in the playlist, and then they're gonna go to the first one. But I think that's probably not the way that most people think, probably. So it might force me to do this introduction on each video where I explain. But then the problem is that if I'm doing the introduction, it's gonna be this annoying thing, because if someone wants to watch the whole playlist, then they're gonna have to listen to the same bullshit introduction all the time. That's the problem I have here. And it's kind of hard to think about a good solution or a good middle ground for that. Maybe I can do the introduction as a separate video, and then I can put the link on the description. Maybe that's the best compromise, I think. But I feel like a lot of people also don't look at the description, but I think that's at least better than what I'm doing now. I don't think I'm gonna do don't think I'm gonna put the introduction before each video because of the thing that I talked about of just being this repetitive thing for someone that is watching the playlist or a bunch of videos should just watch the same introduction. So I think that's a better idea. So I'm gonna do a small video explaining the general picture of how JavaScript and Python are used, and then I'm gonna make that as a separate video. But then, yeah, but I think I'm gonna wait for. So I'm gonna wait to do that then, because I want to finish the playlist first, because in the history of the channel, the sequence of the videos, it's better if the playlist goes from the beginning to the end without any other videos in between, I think. So I think I'm gonna leave to do this thing once I have all the videos on the playlist. And then I can, once I do that video, I can just link that in all the other videos of the playlist. That's what I'm gonna end up doing, I think.
Cache/index.html/styles. Once you have created the app cache manifest, you need to link it to the page that you want to make available offline. You can do this by adding a manifest attribute to the HTML element in the page, and setting its value to the URL of the app cache manifest file. Here is an example of how you might link an app cache manifest to a page. Once the app cache manifest is linked to the page, the browser will automatically cache the specified resources the first time the page is loaded. When the user subsequently loads the page while offline, the cached resources will be used to render the page, allowing the user to access the content even without a network connection. It's important to note that the App Cache API is being deprecated and should no longer be used for new development. Instead, you should consider using other technologies, such as service workers, for caching and offline support. The Geolocation API allows web applications to access the user's location information, if the user has granted permission. By default, the API will use the most accurate location data available, which may involve accessing the user's GPS data, or other location sensors. If you want to configure the Geolocation API to use cached data instead of accessing the user's current location, you can use the geolocation.watchPosition method, which allows you to specify a maximum age for the location data. This maximum age specifies the maximum age of the cached location data that the API is allowed to use. Here is an example of how you might use the watchPosition method to configure the Geolocation API to use cached data. Navigator.geolocation.watchPosition, function, position, / use the position data here, function, error, / handle the error here, maximum age, 30,000 / use cached data up to 30 seconds old. In this example, the watchPosition method is used to request the user's location. The third argument to the method is an options object, which specifies that the API should only use location data that is up to 30 seconds old. If no location data is available that is within the specified maximum age, the API will return an error. It's important to note that using cached data may not always provide the most accurate location information, and it may not be appropriate for all applications. You should carefully consider the requirements of your application and the potential implications of using cached data before configuring the Geolocation API in this way. There are several ways that you can improve the performance of HTML5 graphics in your web applications. Some of the most effective methods include using the canvas element for rendering graphics, instead of using static images. The canvas element allows you to programmatically draw and manipulate graphics on the page, which can be more efficient than using pre-rendered images. Optimizing your graphics. You can improve the performance of your graphics by using smaller, more efficient image files, and by using techniques such as image sprites and CSS transformations to reduce the number of elements that need to be rendered. Using hardware-accelerated rendering. Most modern browsers support hardware-accelerated rendering, which can significantly improve the performance of graphics-intensive applications. You can enable hardware-accelerated rendering by setting the transform, translate 3D, 0,0,0 property on the elements that you want to accelerate. Using a JavaScript library or framework. There are many JavaScript libraries and frameworks, such as 3.js and Pixie.js, that are specifically designed for creating and rendering graphics in the browser. These libraries can provide a higher level of abstraction and make it easier to create complex, performant graphics in your web applications. Overall, the best approach for improving HTML5 graphics will depend on the specific requirements and constraints of your application. You may need to experiment with different techniques and approaches to find the right balance of performance and functionality for your needs. An attribute selector is a type of CSS selector that is used to select elements based on their attributes and attribute values. Attribute selectors allow you to select elements that have a specific attribute, or that have an attribute with a specific value. Here are some examples of attribute selectors. Attribute: this selector will match elements that have the specified attribute, regardless of the attribute's value. For example, a target will match all elements that have a target attribute, even if the attribute's value is empty or undefined. Attribute equals value, this selector will match elements that have the specified attribute with the specified value. For example, a target equals blank will match all elements that have a target attribute with a value of blank. Attribute equals value, this selector will match elements that have the specified attribute with a value that contains the specified word. For example, a class equals external will match all elements that have a class attribute with a value that includes the word external. Attribute selectors can be used in combination with other CSS selectors to create more specific and complex rules for styling elements. For example, you could use an attribute selector to apply a specific style to all links that point to external sites, like this. A target equals blank. Attribute selectors are a powerful tool for targeting elements in your style sheets, and they can help you create more flexible and modular style sheets that are easier to maintain and update. To ensure that a video will render correctly in different browsers, you should use the element and provide multiple sources for the video using the element. This will allow the browser to choose the most appropriate source for the video, based on the browser's capabilities and the available formats. Here is an example of how you might use the and elements to provide multiple sources for a video. Your browser does not support the video tag. In this example, the element is used to embed the video in the page, and the controls attribute is used to enable the default video controls. The elements are used to provide 3 different sources for the video, in different formats, MP4, WEBM, and OGG. When the page is loaded, the browser will choose the first element that it is able to play, based on the type attribute and the browser's capabilities. If none of the provided sources can be played, the text inside the element will be displayed instead. By providing multiple sources for your video in different formats, you can ensure that the video will be able to play in a wider range of browsers and devices, without requiring the user to install additional plugins or software. Free research preview, ChatGPT is optimized for dialogue. Our goal is to make AI systems more natural to interact with, and your feedback will help us improve our systems and make them safer.
So I'm not gonna look at all of this stuff on Git because I think it's just a waste of time. Probably I studied all of them, the ones that are in red, but I don't remember a lot of them. So it will be good to have a refresh on them at some point, but it's not something that is interesting or hard to study. So I don't feel like doing them. I'm just gonna do the ones that are not in red, so I can move on to the next file. And the next one should be what? Oh, C#. C# doesn't have a lot of topics, so I'm gonna do that, so I can finish that one as well. I think I'm gonna look for the ones that have the least amount of topics and then just finish them first, as they take less time. So yeah, let me close this. I'm gonna open this one.
Global scope refers to settings that apply to the current user across all of their repositories on a given system. These settings are stored in the user's global.git config file, which is typically located in the user's home directory. User scope refers to settings that apply only to a specific user on a given system. These settings are stored in the user's .git config file in their home directory, and override any settings in the global.git config file. Local scope refers to settings that apply only to a specific repository. These settings are stored in the repositories.git/config file, and override any settings in the user's .git config file. System scope refers to settings that apply to all users and repositories on a given system. These settings are stored in the system-wide/etc/git config file, and override any settings in the user's .git config file or the repositories.git/config file. In Git, the character caret appended to the end of a commit reference, such as a commit hash or branch name, specifies the parent of that commit. For example, if you have a commit with a hash of ABC123 and you want to reference its parent commit, you could use the syntax ABC123 caret to do so. Note that there are other characters that can be used in a similar way to specify different aspects of a commit's history. For example, can be used to specify a commit's grandparent, i.e., the parent of its parent, and can be used to specify the common ancestor of 2 commits. These characters can be combined and appended to a commit reference in various ways to reference specific commits in a Git repository's history. Free research preview, chat.
Yeah, that's the problem with stuff like this, that is super simple to understand, but you're probably gonna forget because it takes practice to memorize or to remember which one is which, and it's not that important, I think. Hmm. I want to put some music while I put the prompts there. I think I will listen to other music that I'm probably gonna get copyright striked later. But I'm gonna wait for that, I think, because it might close the stream on YouTube. I'm not sure. These are just options from this one. I think I'm gonna do C++ in the same go as I do C#. Oh, this is C. I'm gonna do this. Maybe not. Yeah, I mean just because then it's gonna be too long, the text-to-speech.
In C#, a class is a template for creating objects. To create a class, you use the class keyword followed by the name of the class. For example, class my class / class definition goes here. To create an object from a class, you use the new keyword followed by the name of the class. For example, my class my object equals new my class. You can then access the members of the class, such as fields and methods, using the dot notation. For example, here is an example of a complete class in C# that includes a field, a constructor, and a method. Class my class / field private int my field / constructor public my class, my field equals 0 / method public void some method / method implementation goes here. You can then create an object from this class and call the method as follows. My class my object equals new my class, my object dot some method. I hope this helps. Let me know if you have any other questions. To access the assembly of a running application in C#, you can use the assembly class, which is part of the system.reflection namespace. This class allows you to get information about the assembly, such as its name, version, and the types it contains. Here is an example of how you can use the assembly class to get information about the assembly of a running application. Using system.reflection, / get the assembly of the running application assembly equals assembly.get executing assembly. / get the name of the assembly string assembly name equals assembly.getName, .name, / get the version of the assembly version equals assembly.getName, .version. / get the types defined in the assembly types equals assembly.getTypes. You can then use the information you retrieve from the assembly to access its members, such as types and methods, or to display information about the assembly to the user. I hope this helps. Let me know if you have any other questions. To read data from a file in C#, you can use the file.readAllLines method, which returns a string array containing all the lines in the file. Here is an example of how you can use this method to read data from a file. String lines equals file.readAllLines, C \. This example reads all the lines from the file located at the specified path and stores them in the lines array. You can then iterate over the array to access each line in the file. Here is an example of how you could implement a method that reads data from a file with the following requirements. The method should accept a string parameter that specifies the path of the file to read. The method should return the lines in the file as a list of strings. The method should handle any exceptions that may occur while reading the file, such as if the file does not exist or if the user does not have permission to read the file. Here is an example of how you could implement this method. Using system.io, using system.collections.generic, public list read lines from file, string file path, list lines equals new list, try lines equals file.readAllLines, file path, to list. Catch, io exception x, / handle exception return lines. This example implements the read lines from file method, which accepts a file path as a parameter and returns the lines in the file as a list of strings. The method uses the file.readAllLines method to read the lines from the file and stores them in a list. If an exception occurs while reading the file, the method catches the exception and handles it appropriately. In this case, it just prints the exception message to the console. I hope this helps. Let me know if you have any. To check if an object is null in C#, you can use the == operator to compare the object with the null keyword. Here is an example of how you can use this operator to check if an object is null. If my object equals null, / do something. This example checks if the my object variable is null. If it is, the code inside the if statement will be executed. You can also use the == operator to check if in C#, the null keyword represents a null reference, which is a reference that does not refer to any object. When you compare an object to null, the result will be true if the object is null, and false if the object is not null. I hope this helps. Let me know if you have any other questions. In C#, the garbage collector automatically manages the allocation and release of memory for objects. This means that you do not have to worry about freeing memory manually, and you can use objects without worrying about them using up too much memory. However, in some cases, you may want to make sure that the garbage collector does not release the resources used by an object until the process that uses the object is complete. To do this, you can use the gc.keepAlive method, which instructs the garbage collector not to release the resources used by the specified object until the current process is complete. Here is an example of how you could use the gc.keepAlive method to make sure that the garbage collector does not release the resources used by an object until the process is complete. Using system, / create an object my class my object equals new my class, / use the object my object dot some method, / keep the object alive until the process is complete gc.keepAlive, my object. In this example, the gc.keepAlive method is called after the myObject is used, but before the process is complete. This tells the garbage collector not to release the resources used by the object until the process is complete. Note that you should use the gc.keepAlive method sparingly, as it can prevent the garbage collector from freeing memory that is no longer needed. It is best to use this method only in cases where you specifically need to keep an object alive until the process is complete. I hope this helps. Let me know if you have any other questions.
Yeah, nice. Wonder if I should change this, or if it's gonna give me interesting output if I leave it like this. I think I'm gonna change it. It's weird because this is the C file. And you're saying C++. When asking C. I also want to study the conversion between binaries and decimals again. And maybe the difference between floats and integers on the binaries. But mainly the conversion between binaries and decimals to remember how to do it. Because I know how to do it, but I want to see if I can train my mind to do the conversion faster and more intuitively. Damn, what a long response. I wonder why it chops up the responses like that. Maybe there's a way to change this. Maybe it's a hyperparameter. I feel that that's quite obvious though. So interesting. So maybe I should stop. I think I'm gonna stop after this one and then restart and do again. Because this has a lot of topics here. So it doesn't really remember that much. Like 4,000 words. Don't know how long that is on this articles here. It's probably not much. But it seems it is remembering up until this point. But I guess at each prompt, at each question, you should remember 4,000 additional ones from that question, maybe? think that's it.
A pointer is a variable in C that stores the memory address of another variable. Pointers are a powerful feature of the C programming language that allow a program to manipulate data stored at a memory address. To declare a pointer, you use the asterisk operator in the declaration of the pointer variable. For example, if you have a variable x of type int, you can declare a pointer to x as follows. Int x equals 5, int asterisk p equals and x. This declares a pointer p that stores the memory address of x. The AND operator is used to get the memory address of a variable. To access the value of the variable that a pointer points to, you use the asterisk operator, also known as the dereference operator. For example, to get the value of x through the pointer p, you would write asterisk p. This would evaluate to the value of x, which is 5. Pointers are a fundamental concept in C, and are used in a wide variety of applications, such as dynamic memory allocation and data structures. A static variable in C is a variable that retains its value between function calls. In other words, the value of a static variable is preserved across multiple function calls, so it can be used to maintain a value between those calls. This is in contrast to a local variable, which is created and destroyed every time a function is called and its value is not preserved between calls. To declare a static variable in C, you use the static keyword in the declaration of the variable. For example, static int x equals 5. This declares a static variable x that is initialized to the value 5. When a function accesses x, it will always have the value 5, unless it is explicitly changed by the function. Static variables are often used to maintain state information that needs to be preserved between function calls, such as the number of times a function has been called. They are also commonly used to implement singletons, which are objects that can only be instantiated once, and are used to share information among different parts of a program. Argv is a variable in C that holds the command line arguments passed to a program when it is executed. It is an array of char pointers, with each element of the array holding the address of a null-terminated string that represents a command line argument. The name of the program itself is also included as the first element of the argv array. Argv is typically used in C programs to accept input from the command line, which allows the program to be more flexible and customizable. For example, a program that converts a file from one format to another might take the name of the input and output files as command line arguments, so that the user can specify these files when running the program. To access the command line arguments in a C program, you can use the argc and argv variables. Argc is an integer variable that holds the number of command line arguments passed to the program, including the name of the program itself. Argv is an array of char pointers, with each element of the array holding the address of a null-terminated string that represents a command line argument. Here is an example of how you might use argc and argv in a C program. Int main, int argc, char asterisk argv, if, argc. / the second argument, argv1, is the first command line argument. / this is the input file name in this example. Char asterisk input file equals argv1, / open the input file for reading file asterisk fp equals fpin, input file, r, if, fp equals null, printf, error, unable to open file %s\n, input file, return 1. / read the input file and process it, / close the input file close, fp, return 0. In this example, the main function checks that at least one command line argument was passed to the program, the input file name, and then uses the argv array to access the input file name. It then opens the file for reading and processes it. To get a pointer to the last occurrence of a character in a string, you can use the strrchr function. This function takes a string and a character as arguments, and returns a pointer to the last occurrence of the character in the string. Here is an example of how you might use strrchr to get a pointer to the last occurrence of a character in a string. Char asterisk str equals hello, world, char c equals l, / get a pointer to the last occurrence of l in the string char asterisk ptr equals strrchr, str, c, / print the pointer printf, pointer to the last occurrence of %c, %p \n, c, ptr. In this example, the strrchr function is used to get a pointer to the last occurrence of the character l in the string hello, world. The resulting pointer is then printed. Please note that the strrchr function is part of the C standard library, so you will need to include the string.h header file in your program to use it. Also, the strrchr function only works with null-terminated strings, so you cannot use it with strings that are not null-terminated. If you are working with a child process, you will need to use the appropriate system calls to create and manage the child process. This is beyond the scope of the strrchr function, which is simply a string manipulation function. You can find more information about how to create and manage child processes in C in the documentation for your operating system. To modify a child process without impacting the parent process, you can use the fork system call in C to create the child process. The fork system call creates a new child process that is a copy of the parent process. The child process has its own memory space, so any modifications that it makes to its memory will not affect the parent process. Here is an example of how you might use the fork system call to create a child process and modify it without impacting the parent process. #include #/ for fork, int main, int x equals 5, / create a child process pid equals fork. If PID equals 0, / this is the child process / modify a variable in the child process x equals 10, / print the value of the variable printf, child process, x equals %d \n, x. Else / this is the parent process / print the value of the variable printf, parent process, x equals %d \n, x, return 0. In this example, the fork system call is used to create a child process that is a copy of the parent process. The child process then modifies the value of the x variable, while the parent process retains the original value of x. When the child and parent processes are both finished executing, they each print the value of the x variable, which shows that the modification made by the child process did not affect the parent process. Please note that the fork system call is specific to Unix-like operating systems, such as Linux and Mac OS. If you are using a different operating system, you will need to use the appropriate system calls to create and manage child processes. You can find more information about how to create and manage child processes in the documentation for your operating system. To execute the parent and child processes simultaneously, you can use the fork system call in C to create the child process, and then use the waitbit system call in the parent process to wait for the child process to finish before continuing. The waitbit system call causes the parent process to block until the specified child process has finished executing. Here is an example of how you might use the fork and waitbit system calls to execute the parent and child processes simultaneously. #include // for fork, and waitbit, int main, / create a child process PID equals fork, if, PID equals 0, / this is the child process / do something in the child process, printf, hello from the child process. \n, else / this is the parent process / wait for the child process to finish waitbit, PID, null, 0, / do something in the parent process, printf, hello from the parent process, \n, return 0. In this example, the fork system call is used to create a child process that is a copy of the parent process. The child process then prints a message, while the parent process uses the waitbit system call to wait for the child process to finish before continuing. When both the child and parent processes have finished executing, they will have printed their messages simultaneously. Please note that the fork and waitbit system calls are specific to Unix-like operating systems, such as Linux and Mac OS. If you are using a different operating system, you will need to use the appropriate system calls to create and manage child processes. You can find more information about how to create and manage child processes in the documentation for your operating system. To copy a null terminated string from one array to another, you can use the strcpy function from the C standard library. This function takes two arguments, the destination array, where the string will be copied to, and the source array, where the string will be copied from. Here is an example of how you might use the strcpy function to copy a null terminated string from one array to another. #include // for strcpy, int main, char src equals hello, world. Char dest 100, / copy the null terminated string from src to dest strcpy, dest, src, / print the copied string printf, copied string, %s \n, dest, return 0. In this example, the strcpy function is used to copy the null terminated string from the src array to the dest array. The dest array is declared with 100 elements, which is large enough to hold the copied string and the null terminator. After the string has been copied, it is printed to the console to verify that it was copied correctly. Please note that the strcpy function is part of the C standard library, so you will need to include the string.h header file in your program to use it. Also, the strcpy function does not perform any bounds checking, so you need to make sure that the destination array is large enough to hold the copied string and the null terminator. If the destination array is not large enough, strcpy can cause a buffer overflow, which can lead to security vulnerabilities and other problems. It is recommended to use the strncpy function instead, which allows you to specify the maximum number of characters to copy. In C, the vector type is a data structure that is used to store a sequence of elements. It is similar to an array, but it can grow and shrink dynamically to accommodate the number of elements that are added to or removed from it. The vector type is part of the C++ standard template library, STL, and is not available in standard C. To use the vector type in a C++ program, you need to include the vector header file. #include. Once you have included the vector header file, you can declare a vector variable by specifying the type of the elements that it will hold, followed by the vector keyword and the name of the variable. Vector v. This declares a vector named v that can hold elements of type int. The vector is initially empty, so it does not contain any elements. To add elements to a vector, you can use the pushback method. This method adds an element to the end of the vector, and increases its size by 1. Here is an example of how you might use the pushback method to add elements to a vector. Vector v, / add some elements to the vector v.pushback, 1, v.pushback, 2, v.pushback, 3. This code adds the elements 1, 2, and 3 to the vector v. After these elements have been added, the vector will have a size of 3. To access the elements of a vector, you can use the operator, which takes an index as an argument and returns the element at that index. The first element of a vector has an index of 0, the second element has an index of 1, and so on. Here is an example of how you might use the operator to access the elements of a vector. Vector v, / add some elements to the vector v.pushback, 1, v.pushback, 2, v.pushback, 3, / access the elements of the vector. This code adds the elements 1, 2, and 3 to the vector v, and then uses a for loop to access each element of the vector and print its value. The size method is used to get the number of elements in the vector, and the operator is used to access each element. The vector type is a powerful and flexible data structure that is widely used in C++ programs. It offers many other features and methods, such as insert, erase, and resize, that allow you to manipulate the elements of a vector in various ways. You can learn more about the vector type and its features in the C++ documentation or in a book on C++ programming. To allocate multiple blocks of memory, each of the same size, you can use the malloc function from the C standard library. This function takes a single argument, which is the size of the block of memory to be allocated, and returns a pointer to the beginning of the allocated block. Here is an example of how you might use the malloc function to allocate multiple blocks of memory, each of the same size. Hashtag include // for malloc, int main, / the number of blocks to allocate int numblocks equals 3, / the size of each block size at block size equals size of, int. / allocate the blocks of memory int asterisk blocks numblocks, 4, int I equals 0, I. Exit, 1, / use the blocks of memory, / free the blocks of memory 4, int I equals 0, I. In this example, the malloc function is used in a for loop to allocate numblocks blocks of memory, each of size block size. The malloc function returns a pointer to the beginning of each allocated block, which is stored in the blocks array. After the blocks of memory have been allocated, they can be used as needed. When you are finished with the blocks of memory, you should use the free function to free them, to avoid memory leaks. Please note that the malloc and free functions are part of the C standard library, so you will need to include the stlib.h header file in your program to use them. Also, the malloc function can fail if there is not enough memory available to allocate the requested block of memory. In this case, it will return a null pointer, so you should check for this condition and handle it appropriately in your program. To manage memory and change its size or group it, you can use the malloc, realloc, and free functions from the C standard library. The malloc function is used to allocate memory on the heap, which is a region of memory that is managed dynamically at runtime. It takes a single argument, which is the size of the block of memory to be allocated, and returns a pointer to the beginning of the allocated block. Here is an example of how you might use the malloc function to allocate a block of memory. Hashtag include / for malloc, int main, / the size of the block of memory to allocate size at size equals 10 asterisk size of, int. / allocate the block of memory int asterisk ptr equals malloc, size, if, ptr equals null, printf, error allocating memory \n, exit, 1, / use the block of memory, / free the block of memory free, ptr, return 0. In this example, the malloc function is used to allocate a block of memory that is 10 times the size of an int data type. The malloc function returns a pointer to the beginning of the allocated block, which is stored in the ptr variable. After the block of memory has been allocated, it can be used as needed. When you are finished with the block of memory, you should use the free function to free it, to avoid memory leaks. The realloc function is used to change the size of a block of memory that has been previously allocated with the malloc function. It takes two arguments, a pointer to the beginning of the block of memory to be resized, and the new size of the block. It returns a pointer to the beginning of the resized block of memory, or null if the resize operation failed. Here is an example of how you might use the realloc function to change the size of a block of memory. Hashtag include / for malloc, and realloc, int main, / the initial size of the block of memory size at size equals 10 asterisk size of, int. / allocate the initial block of memory int asterisk ptr equals malloc, size, if, ptr equals null, printf, error allocating memory \n, exit, 1. / use the initial block of memory, / resize the block of memory size at new size equals 20 asterisk size of, int, ptr equals realloc, ptr, new size, if, ptr equals null, printf, error resizing memory \n. In this example, the malloc function is used to allocate a block of memory that is 10 times the size of an int data type. The realloc function is then used to resize the block of memory to 20 times the size of an int. The realloc function returns a pointer to the beginning of the resized block of memory, which is stored in the ptr variable. After the block of memory has been resized, it can be used as needed. When you are finished with the block of memory, you should use the free function to free it, to avoid memory leaks. Please note that the malloc, realloc, and free functions are part of the C standard library, so you will need to include the stlib.h header file in your program to use them. Also, the malloc and realloc functions can fail if there is not enough memory available to allocate or resize the requested block of memory. In this case, they will return a null pointer, so you should check for this condition and handle it appropriately in your program. In summary, to manage memory and change its size or group it, you can use the malloc, realloc, and free functions from the C standard library. These functions allow you to allocate and resize blocks of memory on the heap, and to free the memory when you are done using it. To use these functions, you need to include the stlib.h header file in your program, and you should check for and handle any error conditions that may arise. In addition to the malloc, realloc, and free functions, there are other functions and techniques that you can use to manage memory in C programs. For example, you can use the calloc function to allocate and initialize blocks of memory, you can use the alloca function to allocate memory on the stack. And you can use the map and munmap functions to map and unmap memory from files or other sources. You can also use memory pools, memory arenas, and other techniques to improve the performance and efficiency of your memory management. To learn more about managing memory in C programs, you can consult the C standard library documentation, read books on C programming, or search online for tutorials and examples. There are many resources available that can help you to understand and use the various memory management functions and techniques in C. To share state across threads in a multi-threaded process, you can use shared memory. Shared memory is a memory region that can be accessed by multiple threads within a single process, or by multiple processes on the same computer. This allows the threads to share data and communicate with each other. To use shared memory in a C program, you can use the map and munmap functions from the C standard library. The map function maps a region of memory into the address space of the calling process, and the munmap function unmaps the mapped region and frees the associated memory. Here is an example of how you might use the map and munmap functions to create and use a shared memory region. Hashtag include / for exit, hashtag include / for map, and munmap, hashtag include / for order and ocreat int main, / the size of the shared memory region. Size at size equals 1024, / create the shared memory region int fd equals schmopen, / my shared memory, order creat, 0666, if, fd equals -1, printf, error creating shared memory region \n, exit, 1. / set the size of the shared memory region if, truncate, fd, size, equals -1, printf, error setting size of shared memory region \n, exit, 1. / map the shared memory region void asterisk ptr equals map, null, size, prot read prot write, map shared, fd, 0, if, ptr equals map failed, printf, error mapping shared memory region \n, exit, 1. / use the shared memory region, / unmap the shared memory region if, munmap, ptr, size, equals -1, printf, error unmapping shared memory region \n, exit, 1. / close the shared memory region if, close. In this example, the schmopen function is used to create a new shared memory region with the name /my shared memory. The truncate function is then used to set the size of the shared memory region to 1024 bytes. The map function is used to map the shared memory region into the address space of the calling process, and the munmap function is used to unmap it and free the associated memory when it is no longer needed. To access the shared memory region from another thread within the same process, you can use the same map function to map the region into the address space of the thread. This will return a pointer to the beginning of the shared memory region, which can be used to read and write data in the region. To communicate with other threads, you can use synchronization mechanisms such as mutexes, semaphores, or condition variables to ensure that the threads access the shared memory region in a safe and controlled manner. Please note that the map, munmap, and schmopen functions are part of the C standard library, so you will need to include the appropriate header files in your program to use them. You will also need to check for and handle any error conditions that may arise when using these functions. In summary, to share state across threads in a multi-threaded process, you can use shared memory and synchronization mechanisms such as mutexes, semaphores, or condition variables. These tools allow you to create and manage shared memory regions, and to control access to them by multiple threads. To learn more about these techniques and how to use them in C programs, you can consult the C Standard Library documentation, read books on C programming, or search online for tutorials and examples. Free research.
So insane that a language model can do all of this stuff. I was thinking about. Just from these basic inputs, it just does responds all of this stuff. It's pretty crazy to think about. Oh, fuck. I thought he wasn't over here, but I guess it's responding based on something else, based on the word itself.
To free memory allocated by calloc, you can use the free function in C. Here is an example. Hashtag include int main, / allocate memory for 10 integers using calloc, int * ptr equals calloc, 10, size of, int, / use the memory as needed / free the memory when it is no longer needed free, ptr, return 0. In this example, we use calloc to allocate memory for 10 integers, and then we use free to free the memory when it is no longer needed. It's important to note that calloc and free should be used in pairs, and you should only use free on memory that was previously allocated with calloc. Using free on memory that was not allocated with calloc can lead to undefined behavior. In C, the range of values that can be represented by an integer constant depends on the number of bits used to store the value. In a 16-bit system, the maximum value that can be represented by an integer constant is typically 32,767, and the minimum value is typically minus 32,768. This is because 16-bit systems use 2's complement representation for signed integers, which means that the most significant bit, the leftmost bit, is used to represent the sign of the number. In 2's complement representation, the most significant bit is 0 for positive numbers and 1 for negative numbers. For example, the binary representation of the number 32,767 in a 16-bit system would be 011111111 1111 1111, and the binary representation of the number minus 32,768 would be 1000000000000000. Note that these values are only the maximum and minimum values that can be represented by an integer constant. The range of values that can be represented by an int variable may be different, depending on the specific implementation of the C compiler. In C, the expression void * 0 is a null pointer constant. It is often used to initialize a pointer variable to the null pointer value, which is a special value that indicates that the pointer does not point to a valid memory location. Here is an example of using void * 0 to initialize a pointer. Hashtag include int main, / declare a pointer to an integer int ptr, / initialize the pointer to the null pointer value ptr equals, void, 0, / check if the pointer is null if, ptr equals, void * 0, printf, the
I think I saw a video from Cherno, I think is his name, about this recently, about no, and then he goes on, it's a pretty good video, explains the null value and what is happening. I need to watch that video again. It's very long and difficult to understand. Let's see if I can find it. Let's see, plus journal. Yeah, this guy here. Yeah, this video here.
Have you ever thought about what null actually means? In managed languages such as
I think I'm gonna watch this video as I eat something, probably. The next interval.
Hashtag include int main, / declare a point. In this example, we declare a pointer to an integer and then initialize it to the null pointer value using void * 0. We then check if the pointer is null by comparing it to void asterisk 0 using the equals equals operator. If the comparison evaluates to true, it means that the pointer is null. It's worth noting that the void asterisk 0 expression can be shortened to just null, which is a predefined macro in the C standard library. The null macro is typically defined as void 0, so it has the same value as void 0. Here is the same example using the null macro instead of void asterisk 0. Hashtag include int main, / declare a pointer to an integer int asterisk ptr, / initialize the pointer to the null pointer value. In this version of the example, we use the null macro to initialize the pointer and to check if it is null. This is equivalent to using void asterisk 0 in the previous example. To write to a file in C, you can use the fpin function to open a file in write mode, and then use the printf function to write data to the file. Here is an example. Hashtag include int main, / open a file in write mode file asterisk file equals fpin, mifile.txt, w, / write some data to the file printf, file, hello, world, \n, printf, file, this is some text \n, / close the file close, file, return 0. In this example, we use fpin to open a file called mifile.txt in write mode, and then we use printf to write some data to the file. Finally, we use close to close the file. When the program runs, it will create a new file called mifile.txt in the current directory and write the specified data to the file. If the file already exists, it will be overwritten with the new data. It's important to note that you should always check the return value of fpin to make sure that the file was opened successfully. If fpin returns a null pointer, it means that there was an error opening the file, and you should handle the error accordingly. You should also always close the file when you are done with it using close. Failing to close the file can lead to resource leaks and other problems. If the malloc or calloc functions are not typecast in C, the default return type is void star. This means that the return value of these functions is a pointer to void, which can be assigned to a pointer of any type. Here is an example of using malloc without typecasting. Hashtag include int main, / allocate memory for an integer using malloc, / the return type is void asterisk because we did not typecast void asterisk ptr equals malloc, size of, int. / assign a value to the memory, int, ptr, equals 5, / print the value printf, the value is, %d \n, int, ptr, / free the memory free, ptr, return 0. In this example, we use malloc to allocate memory for an integer, but we do not typecast the return value. This means that the return type is void asterisk, and we have to typecast the pointer when we assign a value to it and when we dereference it to access the value. It's generally a good idea to typecast the return value of malloc and calloc to the appropriate type to avoid having to typecast it every time you use it. This can make your code easier to read and understand, and it can help prevent errors. For example, here is the same example as above, but with the malloc return value typecast to int asterisk. Hashtag include int main, / allocate memory for an integer using malloc, / the return type is int asterisk because we typecast the return value int asterisk ptr equals int asterisk, malloc, size of, int, / assign a value to the memory asterisk ptr equals 5, / print the value printf, the value is, %d \. In this version of the example, we typecast the return value of malloc to int, so the type of the ptr variable is int. This means that we can directly assign a value to the memory using the ptr variable, and we can directly dereference it to access the value without having to typecast it. This makes the code cleaner and easier to read. To read or write a file in text mode in C, you can use the fpin function to open the file in the appropriate mode, and then use the fgets and fputs functions to read and write data from the file. Here is an example. Hashtag include define buffer size 1024 int main, / open a file in read mode file asterisk file equals fpin, mifile.txt, r. / check if the file was opened successfully if, file equals null, perler, error opening file, return exit failure, / read data from the file one line at a time char buffer size, while, fgets, buffer size, file. Equals null, / print the line printf. In this example, we use fpin to open a file in read mode and then use fgets to read data from the file one line at a time. We print each line as we read it. Then, we close the file and open it again in write mode, and we use fputs to write some data to the file. Finally, we close the file again. When the program runs, it will read the data from the file, print it to the screen, and then write new data to the file, overwriting the existing data. It's important to note that you should always check the return value of fpin to make sure that the file was opened successfully. If fpin returns a null pointer, it means that there was an error opening the file, and you should handle the error accordingly. You should also always close the file when you are done with it using close. Failing to close the file can lead to resource leaks and other problems. In this example, we use the R mode to open the file in read mode and the W mode to open the file in write mode. These are the most common modes for reading and writing text files in C. Other possible modes include a for append mode, R+ for read/write mode, and W+ for write/read mode. The specific mode to use depends on the needs of your program. In C, the continue statement is used to skip the remainder of the current iteration of a loop and immediately start the next iteration. Here is an example. Hashtag include int main, / loop through the numbers 1 to 10 for, int I equals 1, I. In this example, we use a for loop to loop through the numbers 1 to 10. Inside the loop, we use an if statement to check if the current number is 5. If it is, we use the continue statement to skip the remainder of the current iteration and immediately start the next iteration. As a result, the number 5 is not printed by the loop. The output of the program will be 1 2 3 4 6 7 8 9 10. It's worth noting that the continue statement only skips the remainder of the current iteration of the loop. It does not terminate the loop or cause it to exit. The loop will continue to run until the loop condition is no longer satisfied. In addition to for loops, the continue statement can also be used with while and do, while loops in C. It can be used to skip the remainder of the current iteration of any of these loop types. In C, the size of operator is used to determine the size in bytes of a given type or variable. The result of the size of operator is always an integer value, and it is typically used to allocate memory or to check the size of data structures. In a 32-bit C implementation, the size of operator applied to the void type will always return 0. This is because the void type is used to represent the absence of a type, and it does not have a size. Here is an example of using the size of operator with the void type. Hashtag include int main, / print the size of. In this example, we use printf to print the size of the void type using the %0 format specifier, which is used to print the result of the size of operator. Since the void type has no size, the output of the program will be the size of void is 0. It's important to note that the size of operator applied to the void type is not very useful, since it always returns 0. In most cases, it is better to use size of with a specific type or variable instead of the void type. Free research preview, ChatGPT is optimized for dialogue. Our goal is to make AI systems more natural to interact with, and your feedback will help us improve our systems and make them safer.
Next one is gonna be C++, I think. I'm gonna leave blockchain for the last because it's the one that I probably studied the most, but I'm not really sure. Maybe React and Next.js as well. See, Rust. It's gonna take a long time. I think out of these ones that are remaining, there's no particular one that I think that I really wanna study first. Doesn't really matter to me. So I think I'll do them sequentially from now on. It's easier to think about it. So C++ is the next one. I'm just waiting for the clock there. I'm gonna take a break now to do this. Maybe I'll do it. I'll put 12. I'll put 15 minutes here, but I'm actually gonna meditate for 10 minutes only. And then I will do 30 minutes, and then I'm gonna pause, to eat something, and watch the video from Cherno. Maybe if this is really fast, then I think after I do C++, I will watch the video from Cherno because it's related to C++. And then I'll read something, and then so it's probably gonna be less than 30 minutes, given that there is not a lot of subjects here. Or maybe I should restart the thing already and put the first topics. Mm, 30. I'll write this one down, then bring it back. Oh, I know that this is 0, so based on the previous one, so I'm not sure if it's useful. I think I'm gonna put there anyways. Size of void. I'll bring it back. think I'm not gonna even put the timer for this because it's probably gonna be fast. So I'm gonna finish this C++ thing here, and then I'm gonna take another break to eat something. And as I eat, I'm gonna watch this video here from Cherno. I watched this already on my other YouTube account, but it's a good video, so I think it's worth it to watch it again. Because I didn't pay too much attention, I think, the first time. Yeah, it's gonna take a long time to finish all of these files. It's a lot of stuff. think I'm gonna count. Maybe after the D3JS. Maybe not. I think after I'm done with this one, I'm gonna count how many files. And then I'm gonna keep track. I think last time for 1 hour and a half, I did 2 files. Maybe 3, but they were small. So see if I spend 1 hour and a half for 2 files, how much I'm gonna get. But I'm gonna keep track on the next 1 hour and a half time interval of how many files I can do. It's not gonna be a precise measurement because the files are different. The size of them are different, but at least should have an idea.
In C++,
It's probably gonna be more than a day though, or more than 24 hours to finish, I assume, but maybe not.
In C++, a pure virtual function is a function that is declared in a base class, but has no implementation in the base class. This means that any class that inherits from the base class
must implement its own version of the pure virtual function, or else the class itself will become a pure virtual class. A pure virtual function is declared by using the virtual keyword in the function declaration, followed by the equals 0 syntax. For example, class base public, virtual void foo, equals 0, class derived, public base public, // must implement foo, or else derived will become a pure virtual class void foo, ****. Pure virtual functions are often used in abstract base classes, which are classes that cannot be instantiated on their own but are designed to be inherited from by other classes. An abstract base class typically contains one or more pure virtual functions, which serve as a template or blueprint for derived classes to implement. This allows the derived classes to provide their own specific implementations of the pure virtual functions while still maintaining the same interface as the base class. In summary, pure virtual functions are a way to define an interface or contract for derived classes to implement, without providing an actual implementation in the base class. The void type in C++ represents the absence of a type. It cannot be used to declare a variable or a function, and it cannot be dereferenced or used in arithmetic expressions. Because of this, it is not meaningful to talk about the size of a void type in bytes. In C++, an abstract class is a class that cannot be instantiated on its own, but is designed to be inherited from by other classes. An abstract class is typically used as a base class for other classes that implement the functionality declared in the abstract class. Abstract classes are created by using the virtual keyword in the declaration of one or more of the class's member functions, followed by the equals 0 syntax. This indicates that the function is a pure virtual function, which means that it has no implementation in the abstract class and must be implemented by any derived class that inherits from the abstract class. For example, consider the following abstract class. Class shape public, // pure virtual function, must be implemented. This shape class declares a pure virtual function named getArea, which returns the area of the shape. It also declares a non-virtual function named printArea, which prints the area of the shape to the console. Because the shape class contains at least one pure virtual function, it is an abstract class and cannot be instantiated on its own. To use an abstract class, you must create a derived class that inherits from the abstract class and provides implementations for all of its pure virtual functions. For example, class circle, public shape public. This circle class derives from the shape class and overrides the getArea function to return the area of a circle with a given radius. Because it provides an implementation for all of the pure virtual functions in the shape class, it is a concrete class that can be instantiated and used like any other class. In summary, abstract classes are a way to define an interface or contract for derived classes to implement, without providing an actual implementation in the base class. This allows you to create flexible hierarchies of related classes that share a common interface but can have different implementations. Encapsulation, inheritance, and polymorphism are three fundamental principles of object-oriented programming, OOP. Together, these principles provide a powerful and flexible way to structure and organize complex programs. Encapsulation refers to the idea of wrapping up data and related behavior, i.e., methods, into a single, self-contained unit called an object. This allows you to hide the internal details of an object and only expose a public interface that other parts of the program can use to interact with the object. Encapsulation helps to reduce code complexity, improve modularity, and prevent unintended side effects from changes to the object's internal implementation. Inheritance is a way for one class, called the derived class, to inherit the properties and behavior of another class, called the base class. This allows you to create hierarchical relationships between classes, where a derived class can inherit and extend the functionality of a base class. Inheritance is a powerful way to reuse and organize code, and it is often used to represent real-world relationships between different types of objects. Polymorphism refers to the ability of different objects to respond to the same message, i.e., method call, in different ways. This allows you to write code that can operate on objects of different types in a uniform manner, without needing to know the specific type of each object at compile time. Polymorphism is often achieved through the use of inheritance, where a base class defines a common interface that can be implemented differently by each derived class. In summary, encapsulation, inheritance, and polymorphism are three fundamental principles of object-oriented programming that work together to provide a flexible and modular way to structure complex programs. In C++,
I'm gonna go back to encapsulation.
Encapsulation refers to the idea of wrapping up data and related behavior, i.e., methods, into a single, self-contained unit called an object. This allows you to hide the internal details of an object and only expose a public interface that other parts of the program can use to interact with the object. Encapsulation helps to reduce code complexity, improve modularity, and prevent unintended side effects from changes to the object's internal implementation. Inheritance is a way for one class.
So it's pretty much like an object.
In C++, a friend function is a function that is declared as a friend of a class. This means that the friend function has access to the private and protected members of the class, even though it is not a member of the class itself. A friend function is declared by using the friend keyword in the class declaration, followed by the function declaration. For example, class my class public, my class, index, xx, private, index, / declare a friend function friend int get x, const my class and obj, / definition of the friend function int get x, const my class and obj, return object x. In this example, the getX function is declared as a friend of the myClass class. This means that it has access to the private X member of the myClass class, even though it is not a member of the class itself. As a result, the getX function can read and return the value of the X member, even though it is private. Friend functions are often used to grant access to private class members to other classes or functions that need to use them, without making the members public. This allows you to maintain the encapsulation and modularity of the class, while still providing a way for other parts of the program to access its internal data. However, it is generally considered good OOP design to avoid using friend functions whenever possible, as they can make it harder to understand the code and make it more difficult to maintain. Instead, it is usually better to use public or protected methods to access private class members in a controlled and consistent manner. In C++, virtual inheritance is a way to ensure that a class only has one instance of a base class, even if it is inherited from multiple times through different paths. This is useful when you have a complex class hierarchy with multiple inheritance, and you want to avoid the potential ambiguity or duplication that can arise from inheriting the same base class multiple times. Virtual inheritance is declared by using the virtual keyword in the inheritance list of a class. For example, class base, class derived 1, virtual public base, class derived 2, virtual public base, class derived 3, public derived 1, public derived 2. In this example, the base class is virtually inherited by both derived 1 and derived 2, which means that if derived 3 inherits from both derived 1 and derived 2, it will only have one instance of the base class, rather than two separate instances. This avoids the potential ambiguity or duplication that would arise if derived 3 inherited two separate instances of the base class. Virtual inheritance is typically used in cases where a class has multiple, independent paths of inheritance from the same base class. For example, consider the following class hierarchy. Class animal / class mammal, virtual public animal / class reptile, virtual public animal / class snake, public mammal, public reptile // Here, the snake class has two independent paths of inheritance from the animal class, one through the mammal class, and one through the reptile class. If the animal class was not inherited virtually in this example, then the snake class would have two instances of the animal class, one through each path of inheritance. This could lead to ambiguity or duplication of data or behavior, depending on how the animal class is implemented. By using virtual inheritance, however, the snake class will only have one instance of the animal class, regardless of how many times it is inherited through different paths. This allows you to avoid these potential problems and create more robust and maintainable class hierarchies. In C++, a void pointer is a special type of pointer that can point to an object of any data type. It is declared by using the void keyword as the pointer's base type. A void pointer is often used when a function or method needs to accept a pointer to an object of any data type, or when a function or method needs to return a pointer to an object of any data type. This allows the function or method to be more flexible and generic, as it can operate on pointers to objects of different types. However, because a void pointer has no inherent type, it cannot be dereferenced directly. Instead, you must first cast the void pointer to another pointer type before you can dereference it. For example, void *ptr / assign the void pointer to point to an int object int x equals 5, ptr equals index, / cast the void pointer to an int pointer and dereference it int *int equals static cast, ptr, std. Could. / cast the void pointer to a double pointer and dereference it double equals static cast, ptr, std could. In this example, the ptr variable is declared as a void pointer and is assigned to point to different objects of different types, an int and a double. To dereference the void pointer, it must first be cast to the appropriate pointer type for the object it points to. This allows the void pointer to be used in a type-safe manner, even though it has no inherent type. In summary, void pointers are a special type of pointer that can point to an object of any data type, but they cannot be dereferenced directly. They are often used to create more flexible and generic functions and methods, but they require careful handling to ensure type safety. In C++, template type parameters are a way to define a generic type that can be used in a class or function template. This allows the class or function to operate on objects of various types, without needing to be explicitly instantiated for each type. Template type parameters are declared by using the type name or class keyword in the template parameter list, followed by a placeholder name for the type. For example, template class my class public, my class, const t end value, t get value, const return value, private, t value. In this example, the my class template has a single template type parameter named t. This parameter can be used to specify the type of the value member variable, as well as the return type of the getValue method. As a result, the myClass class can be instantiated with any type that supports the necessary operations, such as assignment and copy construction. To use the myClass template, you can explicitly specify the type parameter when you instantiate the class. For example, myClass int of j, 5, std could. In this example, the myClass template is explicitly instantiated with the int and std string types, respectively. This creates two concrete classes, myClass and myClass, that can be used like any other class. Template type parameters are a powerful and flexible way to create generic classes and functions in C++. They allow you to write code that can operate on objects of various types without the need for explicit instantiation, making your code more reusable and maintainable. In C++, an array is a contiguous block of memory that is used to store a fixed number of elements of the same type. The type of memory used by an array depends on the type of the array's elements and on how the array is allocated. If the array is a global or static variable, or if it is dynamically allocated using the new keyword, it will be allocated on the heap. The heap is a region of memory that is managed by the program's runtime environment and is typically used for storing data that needs to persist for the entire lifetime of the program. If the array is a local variable or a function parameter, it will be allocated on the stack. The stack is a region of memory that is managed by the program's runtime environment and is used for storing data that is local to a specific function call. In general, the type of memory used by an array in C++ is determined by how the array is allocated and by the lifetime of the data it contains. Global and static arrays, as well as dynamically allocated arrays, are typically allocated on the heap, while local arrays and function parameters are typically allocated on the stack. Free research preview: ChatGPT is optimized for dialogue. Our goal is to make AI systems more natural to interact with, and your feedback will help us improve our systems and make them safer.
I'm gonna get some food. Right back. Also think I'm gonna watch the video when I'm back. So I'm gonna use the other headphone or the other thing, whatever the name is.
C# or Java, if you try and use an object that's null, you'll get a null reference or a null pointer exception. That's because those languages specifically hold your hand. But what about C++? That's what we're going to look into here today. But first, what is the value of null? Well, over here I have some C++ code. Let's go ahead and type in void pointer value, and we'll set it equal to null pointer. Now, there's no null keyword in C++. Instead, we use something called null pointer. If we set a breakpoint on this line over here, I'll make sure my configuration is debug, and I'll hit F5. We'll hit this breakpoint, and if we hover over value, we'll see 0x and then a whole bunch of zeros. Let's look at this value specifically in memory, though. I'm going to go to debug, Windows, memory, and then memory1. And then what I'll do is I'll just type in ampersand value and hit enter. This will take me to the memory address of this actual variable. So we have a void pointer variable stored on the stack, and this is its address. And if we look at the value at that address, we see 8 of these groups of zeros. That's 8 bytes, and they're all set to 0. Why 8 bytes? Because I've built in a 64-bit architecture, and a void pointer, or any pointer, any memory address, is going to be 8 bytes. Okay, so that's your answer. Null pointer is equal to 0. It's stored as 0 in memory. Now, there is one other keyword you may have seen in C++ for null. It's actually not a keyword, but rather a macro, and it's null with capital letters. Now, this is mostly used in C. However, it's totally acceptable to use it in C++ as well, just might not be stylistically appropriate. If we actually go to the definition of this macro, you'll see there's kind of two definitions here. If C++ is defined, it's just 0. Otherwise, in C's case, it would be 0 but explicitly cast to a void pointer. No real difference here. The point is null is defined as 0. So we can just substitute this with 0 if we want. It's the same effect. It just makes your code look a little bit different. And strictly speaking, probably isn't recommended because it adds a little bit extra complexity, I guess. I mean, we like writing our code in English, don't we? So null probably makes more sense than having a pointer set to 0. And it's also perfectly valid to set any integer, really, to null, because remember, null is just 0, and this works. So why wouldn't that work? Especially if it is actually defined to this 0 and not to a void pointer 0, because that will cause problems. So is null really all that scary? I mean, it's just an integer defined to 0, like a number defined to 0. Why is 0 so scary, and why can it crash my program? The problem here comes down to pointers. Pointers are just memory addresses, and 0 is not a valid memory address. So what happens is you will get something called an access violation if you try and read memory that is not valid. And it's not really the memory specifically that's not valid, it's just what memory address the operating system determines is not valid. So if you're trying to specifically read a memory address that does not exist or does not contain memory that you're allowed to access. A good kind of real-world analogy to this is if you type in an address into Google Maps that just physically does not exist. Like you can't go there. So how does all of this work with objects? Well, let's create a class here called entity. I'm just going to give it a default constructor and 2 private variables, maybe a parent entity and a name. Now, because I want to access the name, I'm also going to go ahead and add a getter for that. So const std string reference get name const return name. And I'm also going to write one more function here called print type, which is just going to print the type of the class, which is just entity. So I'm going to go ahead and type in std cout entity. Okay, so I have an entity class with a couple of member variables and a couple of functions. Cool. So how would I create this class in C++? Well, if we want to strictly kind of compare this to managed languages like C# and Java, you'd have to create it on the heap. So we can type in entity equals new entity. This is equivalent to the kind of C# or Java way of creating this, which would be like that. Of course, this is C++, so it would actually be preferable to try and create it on the stack unless you specifically need it to be on the heap. However, we'll just ignore that for now, especially because we're talking about null. So what happens if we just don't set a value for it? So if I just type in entity pointer entity like this, what's going to happen? Well, if I try and use something like get name and I want to print that out, if I run this program, I'm actually not even going to be able to run this program. I'm going to get a build error, and it's going to tell me that I'm trying to use an uninitialized local variable entity. And so what I need to do is explicitly set a value to it. So let's go ahead and just set it to something like null pointer, hit F5, and we'll see what happens. Okay, we get a read access violation. This was 8. Now, why does it say this was 8? We'll get back to that. If we look at our call stack and we go back to the main function, I'll close this memory view. If we scroll down a little bit, we can see that this line of code that crashed, entity is null. So even though the actual kind of crash we got is somewhere inside like std string, if we go back to our code, you can see that the reason this crashed in the first place was because this was null. That's a really important thing to remember when you're debugging this. If you have access violations, go back to your code and see what it is you're trying to access and what the value actually is. If we try and run this in the release configuration, we'll get something slightly different. It's going to tell us that we have an access violation reading location 20 over here, and you can see in this case the debugger actually breaks right on this line. That's because it's optimized a few things and getName probably doesn't even exist anymore. But the point is, we're going to get crashes. They're going to be either access violation or read access violation. Debug gives us a little bit more information, tells us what the value of this is, but overall we know that it's not working. In managed languages, this would be much easier to debug because it would just tell us that entity is null. Whereas in C++, depending on your compiler, depending on a few other things, it's a little bit more cryptic usually. Okay, so we've determined that getName on entity, which is a null pointer, clearly doesn't work because you can't call a function on a null pointer. That doesn't really make sense, does it? Now we do have one other function, print type. So what do you think happens if we call that? If I just call entity print type and entity is null, what's going to happen? Now, while you think about it, let me tell you about Brilliant, the sponsor of this video. If you haven't heard of Brilliant before, you're seriously missing out. Brilliant is an amazing website filled with many, many courses on various STEM topics. Math and computer science go together really, really well. And Brilliant have a lot of really high quality courses on both of those topics. Whether you're just starting to realize the importance of math and want to get started with something easy, or you're trying to learn some more advanced math, perhaps for 3D graphics, Brilliant have got you covered. And if it's specifically computer science you're interested in, maybe you want to learn more about neural networks, they are one of the best places to check out for that because all of their courses are extremely interactive and engaging. They have these beautiful widgets that you can play with to make sure that you visually understand what's going on. And they'll also continually quiz you to make sure that you're actually learning and retaining the information. And guess what? You can get started for free. Just go to brilliant.org/thechannel, check it out for yourself, just scroll through their courses, see if you find something that you like. It's free. There's no reason not to do it. And if you do find a bunch of courses that you like and want to spend more time on the platform, Brilliant have been nice enough to offer the first 200 of my subscribers 20% off an annual membership. Huge thank you, as always, to Brilliant for sponsoring this video. Okay, well, entity print type, it's null. Let's go ahead and run this code. I'm going to stop it right here, though. I'll hit F5, and, whoop, well, I don't see any access violation. Let's take a look at our console, and check this out. It printed entity. So it did exactly what the function said. And if I just hit F10, okay, now I get an access violation. So what seems to be happening is if I just comment out this line for a minute, I'll remove all my breakpoints, I'll hit F5, my program runs successfully, unlike in managed languages where you would get a null pointer or a null reference exception. So how come this works, but this doesn't work. And does this even make sense that this works? I mean, this object is null, so what is it calling print type on? That doesn't make any sense. Well, let's scroll up a little bit and talk about how methods actually work. These are functions within a class. They're not static functions or anything like that. They're member functions. We usually call them methods in object-oriented programming. I usually just call them functions or member functions, though, between you and me. So when the compiler is compiling this program and it's looking at this class, work? Well, if you actually think back to C, then there's no such thing as a class. There is a struct, which is kind of the same thing. However, structs cannot have functions inside them. So let's talk about how we would go about rewriting this class in C. Well, we go down here, we create a struct called entity. I'm going to call it entity data just so that it's a different name. I'm going to copy these two members. So we can have a structure of different variables, that's fine. I'll just change this to be entity data so we're pointing to our same type here. And then how would we get these functions to work? Well, we just write them outside of the class, right? So I'll copy them over here. I'll get rid of this const, and maybe I'll just add a little leading entity over here just so that we know that it's kind of supposed to be a function of this particular class, even though it's just a free-floating function, of course. Okay, cool. Well, the first problem is we have to return name, but name is obviously relative to a particular instance of this struct. So what do? Well, we need to actually take in that struct as a parameter. This is exactly what happens in C++ when we actually compile this class. The methods inside the class, the functions inside the class get converted into just regular free-floating functions that actually take in an instance of the class as their first parameter. And guess what that instance is called? This. Now in this case we can't name it this because that's a reserved keyword, so let's just go ahead and name it self. And then mname obviously comes from self. So now this makes sense because mname is coming from this particular instance. We actually now have a way to get that specific data we want to return. Now one minor addition here, the original function was actually labeled as const, which means that the self that gets taken in here, this pointer that gets taken in, is actually a const pointer like this. And with print type, the exact same thing happens. Now print type is not marked as const. So what would happen is we take in this, obviously, but it's not going to be const. And just for example's sake, if print type had been a static function like this, then it just wouldn't take in the instance. That's why you can never access a member, such as mparent or something like that, from within a static function. You can't do that because a non-static member reference must be relative to a specific object. And if we don't take in a specific object in the first place, then of course we can't possibly access the data, unless it is also static, because in that case, it knows where the data lives. So back to our normal example. So what happens if we try and call getName, but entity is null? Well, it means that the self that is passed in here is null. And what are we trying to do? We're trying to specifically access a string from null, right? This is 0. We're trying to access its name and return it as an actual string reference, which means that we're going to read that memory address, a memory address that is invalid, and thus we crash. Now let's scroll down to this function. Do you see the difference here? Okay, we also call entity print type. Entity is in fact null pointer, so self is null, but then, like, what do we do here? We just print out the word entity, followed by a new line. Do we access self at all? No, we don't. We don't care about self at all. This may as well be like a static function because we don't even use self or this pointer. So that is why this doesn't crash, because it's not the fact that you're actually calling a function on null. That's perfectly valid because remember, it's not like this function exists within the actual entity class. It's not physically existing inside here. It gets compiled out into something like this by the compiler. It's just a normal function. Inside our compiled binary, there's just a bunch of CPU instructions. There's just a bunch of machine code at a particular address inside that binary that gets loaded up into memory. And the instruction pointer will simply jump to that address and start executing instructions. It's not like it magically lives inside that object, and if the object is null, it's not going to work. So the thing that causes the crash is the fact that we're actually trying to use these member variables, and they can't be accessed because the object itself, the instance, is null. And to further demonstrate this case, let's talk about a little something. Let's talk about a macro called offset of. Now, offset of is a pretty cool macro. What it will do is it lets you pass in the name of a class, such as entity. I might just use entity data here, but it's the same thing. And then the name of a member variable, such as mname. And what it will do is it will actually give you the offset of that particular member in memory. So if I bring this code down over here, offset of mname, and we print that offset, let's hit F5, you can see the offset of mname is 8. So we can use this macro to actually tell us what the offset of this is in memory. Why is it 8? Because this mparent variable is obviously the very first thing in the struct, so it's going to be at an offset of 0. And then what is its size? Well, it's a pointer on a 64-bit architecture, so it's going to be 8 bytes, which puts mname at an offset of 8, meaning the first 0 through 7 inclusive bytes are occupied by this variable, and then the next, however many bytes a string takes, from byte 8 onwards, is occupied by this variable. But how does offset of know that? How exactly does it work? Well, if we actually go to the definition of it, there's a couple different definitions depending on, again, whether or not this C++ macro is defined, but both of them will technically work in C++. We're going to look at the bottom one just because it's a little bit more concise. You can see what it's doing, and it's pretty simple. We take in two variables here, s and m. Now, s is entity data, and m is mname. So this is entity data. What we're doing is we're basically casting 0 to be an entity data pointer. Then we're going to that member variable, getting the memory address of it, and casting that to a size t. So if we were to write this ourselves, then offset would be equal to entity data pointer 0, right? So this is step 1. This is a null pointer, and you can actually use a null pointer if you want. It's the same thing. And relative to that null pointer, we're actually looking up that specific member variable, the specific member variable that caused the crash earlier. But how come this is working? Well, the crucial difference is that we're not actually looking at the value of it. We're not trying to read the memory at this address because that would be a read access violation. What we're doing is we're actually getting the memory address of that variable. So in other words, where is this located in memory? And since it's relative to 0, then that gives us the offset. If it was relative to an actual entity data allocation, so we actually created a new entity data here, and then we tried to look at name, of course that would be relative to whatever address this actually gets allocated at. But since we are specifically looking at it from this kind of 0 pointer, it means that this will in fact just be the offset. And then the final step is to cast this, which is going to be a string pointer, because mname is a string. We can just pass that to something like a UN64T or a size t as a macro we're doing, and that gives us our offset. And if we try and run this program, we will of course get the exact same result. And if we try and run it with null pointer, then of course we'll also get the same result. And if we actually take this breakpoint away so that it tries to run valid code, as we did earlier in the video, and it said that this was a problem is that string is located at an offset of read from that specific value, and that of course is wrong. So again, it's not the fact that this specific self is null here when it tries to actually return the name, it's the fact that we're then trying to print it, which means it has to access the string, which means when it asks the string for its address, it is going to be at an offset of 8 to entity, and entity is null. So 0 plus 8 gives us 8, and we get a little message, telling us that this was 8, which is a read access violation. We can't read from that memory address because that's not valid memory. And that is what null is. Hopefully this video was helpful to you guys. If you liked it, please don't forget to hit the like button below. If you have other suggestions for C++ videos, leave them in the comments below. Don't forget to check out brilliant.org/journo, and I will see you guys next time. Goodbye.
Think it broke here. So I'm gonna do this and then restart the thing.
The d3.select method. The d3.select method in d3.js is used to select an element from the document. This method takes a CSS selector string as an argument and returns the first element that matches the given selector. For example, the following code would select the first element on the page and set its text color to red. d3.select p.style color red. If you want to select multiple elements, you can use the d3.selectAll method instead, which returns a selection of multiple elements. You can then use the various methods available on the selection to operate on all of the selected elements at once. Here's an example that sets the text color of all elements on the page to red. d3.selectAll p.style color red. It's important to note that the d3.select and d3.selectAll methods only return a reference to the selected elements and do not make any changes to the document itself. To actually modify the document, you will need to use other methods, such as style or iter, to make the desired changes. D3.js is a powerful data visualization library that allows you to create a wide variety of charts and graphs from data. To visualize data with D3.js, you need to follow these steps. Load the data. D3.js can load data from a variety of sources, such as CSV, TSV, JSON, and even HTML tables. You can use the D3.csv, D3.tsv, D3.json, or D3.html method to load the data into your script. Transform the data. Once the data is loaded, you will need to transform it into the format that you want to use for your visualization. This may involve sorting, filtering, or grouping the data in various ways. Create the visualization. Once the data is in the right format, you can use the various D3.js methods and functions to create the visualization. This may involve creating scales, axes, and other visual elements, as well as drawing the data itself. Customize the visualization. Finally, you can use various D3.js methods and functions to customize the appearance and behavior of your visualization. This may involve adding labels, legends, or interactivity to the visualization. Here's a simple example that shows how to create a bar chart using D3.js. / load the data D3.csv, data.csv, function, data, / transform the data data.sort, function, a, b, return a.value, b.value. / create the visualization var svg equals d3.select, body, .append, svg, .iter, width, 800, .iter, height, 400, var x scale equals d3.scale linear, .domain, 0, d3.max, data, function, d, return d.value. .range, 0, 800, var y scale equals d3.scale band, .domain, data.map, function, d, return d.name, .range, 0, 400, var bars equals svg.select all, rect, .data, data, .enter, .append, rect, .iter, x. 0, .iter, y, function, d, return y scale, d.name, .iter, width, function, d, return x scale, d.value, .iter, height, y scale, .bandwidth. / customize the visualization svg.append, g, .iter, This example loads data from a CSV file, sorts the data by value.
I don't think it's useful to do this one again next time. So I don't think it was gonna say anything useful after. Just gonna explain the code. It's not that hard to understand. Oh, I'm gonna count how many files. So, so 22 files. Oh, and I forgot to put the timer. I'm gonna start counting now. But it's gonna be less than one file, so... But at least I can get a rough estimation. And hopefully it doesn't start crashing all the time. Maybe I just made too many inputs. And I should try to close the site and try again, or click the reset rather and stuff. Yeah, I think it's not worth waiting. We're just gonna do this.
In D3, you can use the mouse method to get the current mouse position relative to the specified container element. Here's an example of how you might use this method. Const svg equals d3.select, hashtag mysvg, / select the svg element svg.on, mouse move, equals const x, y equals d3.mouse, svg.node, / get the mouse position console.log, mouse position, $x, $y. In this example, we select the svg element and attach a mouse move event listener. Inside the event listener, we use the d3.mouse method to get the current mouse position, and then we log it to the console. Note that the mouse method returns the position in pixels, so you may need to convert the coordinates to the appropriate scale if your data is not in pixels. For example, if your data is in a geographic projection, you can use the invert method on the projection to convert the coordinates from pixels to longitude and latitude. D3.scaleLinear is a D3 method for creating a linear scale. A linear scale is a type of quantitative scale that maps a continuous input domain to a continuous output range. This means that the scale will take an input value, such as a data point, and map it to a corresponding output value within the specified range. Here's an example of how you might use D3.scaleLinear. Const scale equals d3.scaleLinear.domain 0 100 / the input domain.range 0 500 / the output range console.log scale 50 / 250. In this example, we create a linear scale using d3.scaleLinear. We then specify the input domain using the domain method and the output range using the range method. In this case, our input domain is 0 100, which means the scale will take any input value between 0 and 100. Our output range is 0 500, which means the scale will map the input values to output values between 0 and 500. Finally, we use the scale by calling it as a function and passing in the input value, 50 in this case. The scale will return the corresponding output value, 250 in this case. You can use a linear scale in D3 to create axes for a chart, to map data values to visual properties, such as position or color, or to perform other types of data transformations. The HTML element is stateless, which means that it does not maintain a persistent state between rendering operations. This means that, after you draw something on an element, the element will not remember what you drew. For example, if you draw a circle on an element, and then draw a rectangle on top of it, the will not remember the circle. If you want to draw the circle again, you will need to redraw it using the appropriate drawing methods. However, even though the element itself is stateless, you can use JavaScript to maintain a persistent state and keep track of the elements you have drawn on the canvas. This allows you to redraw elements on the canvas as needed, or to manipulate the elements in other ways. Here's an example of how you might use JavaScript to maintain a persistent state for an element. Const canvas equals document.querySelector, hashtag mycanvas, const ctx equals canvas.getContext, 2D, const elements equals / an array to store the elements we have drawn / a function to draw a circle on the canvas const draw circle equals x, y, radius, equals const circle equals type, circle, x, y, radius. Elements.push, circle, / add the circle to the array of elements / draw the circle on the canvas ctx.beginPath, ctx.arc, x. In this example, we create an array called elements to store the elements we have drawn on the canvas. We then define a function called drawCircle that takes the coordinates and radius of a circle and draws it on the canvas. The function also adds the circle to the elements array. We also define a function called redraw that clears the canvas and then loops through the elements array, redrawing each element on the canvas. Finally, we use the drawCircle function to draw a circle on the canvas. Later, we can call the redraw function to redraw all the elements on the canvas, including the circle we drew earlier. Free research.
Oh, that's why. Oh. So it is on my stuff. Yeah, so I guess there's nothing I can do besides waiting or doing this a bunch of times. I wonder how many is actually exceptionally high for them, given that they said that on the first 3 days there were 1 million people using it. And I guess because it's Sunday, there's probably a lot of people using it at the same time. Probably because a bunch of people made videos about it as well. probably increase that exponentially. this one is gonna take a long time. And it's probably gonna be very hard to read it.
SVG, or Scalable Vector Graphics, is a type of vector image format that is used to display images on the web. It is a stateless language, which means that it does not retain any information about the previous state of the image. This means that changes made to an SVG image are not automatically applied to the image itself, but must be explicitly specified in the code. This allows for greater control and flexibility when creating and modifying SVG images. jQuery and D3 are both JavaScript libraries that are commonly used to manipulate the document object model, DOM, and create dynamic and interactive data visualizations on the web. However, there are some key differences between the two libraries. First, jQuery is a general-purpose library that is designed to make it easier to select, manipulate, and traverse the DOM. It provides a number of convenient methods for working with DOM elements, and it is widely used for tasks such as event handling and animation. In contrast, D3 is a library specifically designed for data visualization. It allows developers to create complex and highly customizable visualizations using data from a variety of sources, including HTML tables, CSV files, and JSON objects. Another key difference between the two libraries is their approach to data manipulation. jQuery provides a number of high-level methods for working with data, such as .each and .map, which are designed to make it easier to iterate over collections of data and transform them into the desired format. D3, on the other hand, takes a more low-level approach to data manipulation, providing a variety of functions and methods that allow developers to explicitly specify how data should be transformed and combined. In short, jQuery is a general-purpose library that is well-suited to a wide range of web development tasks, while D3 is a specialized library for creating data visualizations. While the two libraries can be used together to create powerful and interactive web applications, they are often used for different purposes and require different skill sets to master. Path generators are functions or algorithms that are used to create and draw geometric shapes, such as lines, curves, and polygons, on a two-dimensional plane. In the context of data visualization, path generators are often used to create visualizations of data that have a spatial component, such as maps or scatter plots. Path generators typically take a set of input data, such as a collection of coordinates, and use that data to generate a path or series of paths that can be rendered as a visual representation of the data. Different path generators may use different algorithms and techniques to create paths, depending on the specific requirements of the visualization being created. For example, a path generator for creating a choropleth map might use geometric shapes to represent different regions, while a path generator for creating a scatter plot might use lines or curves to connect individual data points. In addition to creating paths, many path generators also provide methods for modifying and styling the paths they create. For example, a path generator might provide methods for setting the color, thickness, or line style of the paths it creates, as well as methods for applying transformations, such as rotation or scaling, to the paths. Overall, path generators are an important tool for creating dynamic and interactive data visualizations, and are often used in conjunction with other libraries and frameworks, such as D3.js. To create sophisticated and visually engaging visualizations. The .select method is a commonly used method in the D3.js library for selecting elements in the document object model, DOM. This method allows developers to select one or more elements in the DOM based on a specified selector, such as an element type, class name, or ID. For example, the following code uses the .select method to select all elements on the page. D3.selectAll, p. Once an element or group of elements has been selected, developers can use other D3.js methods to manipulate and modify those elements, such as setting attributes or applying transformations. The .select method is often used in conjunction with other D3.js methods, such as .data and .enter, to create dynamic and interactive data visualizations. For example, the following code uses the .select method to select an element with the ID chart, and then uses the .data and .enter methods to bind data to that element and create new elements for each data point. D3.select, #chart, .selectAll, p, .data, data, .enter, .append, p. In summary, the .select method is a powerful and versatile tool for selecting elements in the DOM, and is an essential part of the D3.js library for creating data visualizations. Sliders are a common user interface element that is used to adjust a numerical value within a specified range. In D3.js, sliders can be created using a combination of SVG elements and JavaScript code. To create a slider in D3.js, developers can use the element to create the background of the slider, and the element to create the slider handle. The position of the slider handle can be controlled using the .iter method to set the x1, y1, x2, and y2 attributes of the element. In addition to the SVG elements, sliders in D3.js also require some JavaScript code to handle user input and update the position of the slider handle. This can be done using event listeners, such as .on, mouse move, and .on, mouse down, to detect when the user moves the mouse over the slider or clicks on the slider handle. The position of the slider handle can then be updated using the .iter method to set the new x1, y1, x2, and y2 attributes of the element. Here is an example of how to create a simple slider in D3.js. / create the background of the slider var background equals svg.append rect.iter x.iter y.iter width.iter height.iter fill light gray / create the slider handle var handle equals svg.append line.iter x1 x.iter y1 y plus height /2.iter x2 x / handle user input to update the position of the slider handle background.on mouse move. In summary, sliders can be created in d3.js using a combination of svg elements and JavaScript code. The n elements are used to create the visual appearance of the slider, while event listeners and the .iter method are used to handle user input and update the position of the slider handle. D3.js is a JavaScript library for creating data visualizations on the web. One of the key features of D3.js is its support for scales, which are functions that map data values to visual encodings, such as pixel positions or colors. D3.js provides several types of scales, including linear scales, log scales, and quantized scales. Linear scales are the most commonly used scales in D3.js, and are used to map data values onto a continuous range of output values. For example, a linear scale might be used to map a range of data values onto a range of pixel positions, such as mapping a set of temperatures onto a range of x-coordinates on a line chart. Linear scales can be either continuous, where the output range is also continuous, or discrete, where the output range is a set of discrete values. Log scales are a type of scale that is used to map data values onto a logarithmic scale. This type of scale is useful for visualizing data that has a large range of values, or data that follows an exponential growth pattern. Log scales can be either continuous, where the output range is also continuous, or discrete, where the output range is a set of discrete values. Quantized scales are a type of scale that is used to map data values onto a discrete range of output values. This type of scale is useful for visualizing data that can be divided into a finite set of categories, such as the colors of a traffic light. Quantized scales provide a convenient way to map data values onto a set of predefined outputs, such as a set of colors or a set of categories. In addition to linear, log, and quantized scales, D3.js also supports several other types of scales, including time scales, band scales, and sequential scales. Each of these scales has its own specific use cases and features, and can be combined with other D3.js features, such as axes and labels, to create sophisticated and engaging data visualizations. Yes, D3.js is a data-driven library, which means that it is designed to work with data and allow developers to create data-driven visualizations. D3.js provides a number of methods and functions for loading, parsing, and manipulating data, as well as for binding data to the document object model, DOM, and creating visualizations based on that data. One of the key features of D3.js is its support for data joins, which allows developers to bind data to elements in the DOM and update those elements as the data changes. This allows developers to create dynamic and interactive visualizations that automatically update as the underlying data changes. In addition to its support for data joins, D3.js also provides a number of other features that make it well suited to working with data. These features include support for a wide range of data formats, such as CSV, JSON, and HTML tables, as well as support for transformations and aggregations that allow developers to manipulate and summarize data before creating visualizations. Overall, D3.js is a powerful and flexible library for creating data-driven visualizations on the web. Its support for data joins, data formats, and data transformations make it an essential tool for anyone working with data and creating visualizations on the web. D3.js is a JavaScript library that is commonly used for manipulating the document object model, DOM, in order to create dynamic and interactive data visualizations on the web. D3.js provides a number of methods and functions for selecting, modifying, and creating DOM elements, as well as for binding data to those elements and applying transformations to them. To manipulate the DOM with D3.js, developers typically use the .select and .selectAll methods to select one or more elements in the DOM. For example, the following code uses the .selectAll method to select all elements on the page. D3.selectAll, p. Once an element or group of elements has been selected, D3.js provides a number of methods for modifying those elements, such as the .iter method for setting attributes, the .style method for setting CSS styles, and the .text method for setting the text content of the element. For example, the following code uses the .iter method to set the fill attribute of all elements on the page to the color red. D3.selectAll, rect.iter, fill, red. In addition to modifying existing elements, D3.js also provides methods for creating new elements in the DOM. This is often done in conjunction with data binding, where data is used to create new elements in the DOM based on the values in the data. For example, the following code uses the .data and .enter methods to bind data to an element and create a new element for each data point. D3.select, #chart, .selectAll. In summary, D3.js is a powerful library for manipulating the DOM and creating dynamic and interactive data visualizations on the web. Its support for data binding, selection, and modification of elements makes it an essential tool for any developer working with data and visualizations on the web. D3 Interaction and Animation, Custom Visualizations. D3.js is a JavaScript library for creating data visualizations on the web. One of the key features of D3.js is its support for interaction and animation, which allows developers to create visualizations that are dynamic and engaging. D3.js provides a number of methods and functions for creating custom visualizations, such as pie charts, bar charts, and geospatial maps, as well as for adding transitions and other animations to those visualizations. To create a custom visualization with D3.js, developers typically start by selecting one or more elements in the document object model, DOM, and binding data to those elements. For example, the following code uses the .selectAll and .data methods to bind data to a set of elements. D3.selectAll, rect.data, data. Once the data has been bound to the elements, developers can use a variety of D3.js methods and functions to create custom visualizations and add animations to those visualizations. For example, the following code uses the .enter method to create new elements for each data point, and the .iter method to set the position and size of those elements based on the data. D3.selectAll, rect.data, data.enter, .append. To add animations to a visualization, developers can use the .transition method to specify the duration and easing of the animation, and then use the .iter method to set the attributes of the elements that will be animated. For example, the following code uses the .transition method to animate the position of a set of elements over a period of 1 second, using a linear easing function. D3.selectAll, rect.transition. In summary, D3.js is a powerful library for creating custom visualizations and adding interactions and animations to those visualizations. Its support for data binding, selection, and modification of elements, as well as its support for transitions and other animations, make it an essential tool for creating dynamic and engaging data visualizations on the web. D3.js is a JavaScript library for creating data visualizations on the web. One of the key features of D3.js is its support for loading data from external files, such as CSV, JSON, and TSV files. D3.js provides a number of methods and functions for loading and parsing data from external files, as well as for binding that data to elements in the document object model, DOM, and creating visualizations based on that data. To load data from an external file with D3.js, developers typically use the D3.csv, D3.json, or D3.tsv function to load the data from the file. And then use the .then method to specify a callback function that will be called once the data has been loaded. For example, the following code uses the D3.csv function to load data from a CSV file, and then uses the .then method to specify a callback function that will be called with the data once it has been loaded. D3.csv, data.csv, .then, function, data, // data is now available to use in the callback function. Once the data has been loaded, developers can use a variety of D3.js methods and functions to bind the data to elements in the DOM and create visualizations based on that data. For example, the following code uses the .data and .enter methods to bind the data to a set of elements and create new elements for each data point. D3. Once the data has been loaded and bound to elements in the DOM, developers can use a variety of D3.js methods and functions to create visualizations based on that data. For example, the following code uses the .iter method to set the position and size of the element. In summary, D3.js provides a number of methods and functions for loading and parsing data from external files, as well as for binding that data to elements in the DOM and creating visualizations based on that data. Its support for loading data from a wide range of file formats, as well as its support for data binding and visualization creation, make it an essential tool for anyone working with data and visualizations on the web. Free research.
Oh, I think it's fucked. Maybe I should tell them or send an email or something. I don't know how I can... Because I think this is a common thing whenever he's writing code and the limit of the outputs, it gets to the limit of the output, then it stops working. I think that's what's happening here. Damn, and it's talking about the queen problem before I even type it. Maybe it's just a coincidence. Or maybe because I typed here. Or it's just a common... I think it's because of... I remember this had a arrow there, so it's probably... It was probably a question about options, and then the end queen problem is probably usually associated with backtracking. That's probably why it's talking about the queen problem before I typed there. Or maybe this will happen a lot as well on this file because it's all about algorithms. But I think I'm gonna turn on the text-to-speech already. Then just reset this.
Prim's algorithm is a method for finding the minimum spanning tree of a weighted graph. It starts by selecting an arbitrary vertex as the starting point and adds the edge with the smallest weight that connects the tree to a new vertex. This process is repeated until all the vertices in the graph are included in the tree. Here is an example of how Prim's algorithm works. Let's say we have the following graph. A-5-b //436 //c-2-d. We start by selecting an arbitrary vertex, let's say A. The minimum spanning tree at this point is just the vertex A itself. Next, we look for the edge with the smallest weight that connects the tree to a new vertex. In this case, the edge with the smallest weight is the one that connects A to C, with a weight of 4. We add this edge to the tree, and the tree now looks like this. A 4C. Next, we again look for the edge with the smallest weight that connects the tree to a new vertex. In this case, the edge with the smallest weight is the one that connects C to D, with a weight of 2. We add this edge to the tree, and the tree now looks like this. A 4C2D. Now, we again look for the edge with the smallest weight that connects the tree to a new vertex. In this case, there are two edges with the smallest weight, the one that connects A to B, with a weight of 5, and the one that connects C to D, with a weight of 3. We can choose either edge to add to the tree. Let's say we choose the edge that connects A to B. The tree now looks like this. A-5-b 4C-2-d. We repeat this process until all the vertices in the graph are included in the tree. In this case, the next edge we add would be the one that connects B to D, with a weight of 6. This completes the minimum spanning tree, which looks like this. A-5-b 46C-2-d. In summary, Prim's algorithm is a simple and effective way of finding the minimum spanning tree of a weighted graph. It works by repeatedly adding the edge with the smallest weight that connects the tree to a new vertex, until all the vertices in the graph are included in the tree. A binary search tree, BST, is a type of tree data structure in which each node has at most 2 children, left and right, and each child of a node is identified as either a left or right child. In addition, the values in the left subtree of a node are less than or equal to the value of the node, and the values in the right subtree of a node are greater than the value of the node. This property, known as the BST property, allows for efficient search, insertion, and deletion operations on the data in the tree. Here is an example of a binary search tree. 8//310//1614//1614//0271315. In this example, the value at the root of the tree is 8, the values in the left subtree are less than or equal to 8, and the values in the right subtree are greater than 8. For instance, the value 3 is in the left subtree of the root because it is less than 8, and the value 10 is in the right subtree of the root because it is greater than 8. One of the key advantages of a binary search tree is that it allows for efficient search operations. To search for a value in a BST, we start at the root of the tree and compare the value we are searching for with the value at the root. If the value we are searching for is less than the value at the root, we move to the left subtree and repeat the process. If the value we are searching for is greater than the value at the root, we move to the right subtree and repeat the process. This process is repeated until we either find the value we are searching for, or we reach a null child, in which case the value is not in the tree. In the example above, to search for the value 6, we would start at the root and compare 6 to the value at the root, which is 8. Since 6 is less than 8, we move to the left subtree and compare 6 to the value at the root of the left subtree, which is 3. Since 6 is greater than 3, we move to the right subtree of the left subtree and compare 6 to the value at the root of the right subtree, which is 6. Since 6 is equal to 6, we have found the value we were searching for, and the search is complete. Overall, a binary search tree is a useful data structure for storing and organizing data in a way that allows for efficient search, insertion, and deletion operations. Auxiliary space complexity, also known as extra space complexity, is a measure of the amount of memory that an algorithm uses beyond the amount of memory required to store the input data. This additional memory is used for storing temporary variables, holding the results of intermediate calculations, or performing other operations that are necessary for the algorithm to run. Auxiliary space complexity is often contrasted with time complexity, which is a measure of how long an algorithm takes to run as a function of the size of the input data. Time complexity and auxiliary space complexity are both important factors to consider when evaluating the efficiency of an algorithm, and they can sometimes trade off against each other. For example, an algorithm that uses a lot of auxiliary space may be able to run faster because it can store and access intermediate results more quickly, while an algorithm that uses less auxiliary space may be slower because it has to repeat calculations or perform other operations more often. To calculate the auxiliary space complexity of an algorithm, we need to identify all the temporary variables, intermediate results, and other data structures that the algorithm uses, and determine how the amount of memory required to store them varies with the size of the input data. For example, if an algorithm uses an array to store intermediate results, the auxiliary space complexity would be the size of the array, which would typically be proportional to the size of the input data. Here is an example of how auxiliary space complexity can be calculated for a simple algorithm that sorts an array of numbers. Function sort array, create an empty array to hold the sorted results. Let result equals / loop through the input array and add each element to the result array in sorted order for, let I equals 0. I. In this algorithm, the auxiliary space complexity is determined by the size of the result array, which is used to hold the sorted results. Since the size of the result array is proportional to the size of the input array, the auxiliary space complexity of this algorithm is linear, or O, n, where n is the size of the input array. In summary, auxiliary space complexity is a measure of the amount of memory that an algorithm uses beyond the amount of memory required to store the input data. It is an important factor to consider when evaluating the efficiency of an algorithm, along with time complexity and other factors. A priority queue is a data structure that stores items with associated priorities and allows for efficient retrieval of the item with the highest priority. In a priority queue, items with higher priorities are given precedence over items with lower priorities. Priority queues are often implemented using a heap data structure. A heap is a type of binary tree in which the parent node is always greater than or equal to, in the case of a max heap, or less than or equal to, in the case of a min heap, its children. This property, known as the heap property, allows for efficient insertion and removal of items from the heap. Here is an example of a priority queue implemented using a min heap. 5/89/89/11 In this example, the min heap has the following items and priorities: 5, priority, 3. 8, priority, 2. 9, priority, 1. 11, priority, 4. 14, priority, 6. 13, priority, 5. 19, priority, 7. To retrieve the item with the highest priority, we simply remove the root of the min heap, which is the item with the lowest priority. In this case, the root is the item with priority 1, which is 9. After removing the root, we must restore the heap property by bubbling down the new root, in this case, 5, until it is in the correct position. This results in the following min heap: 5/811/811/141319. To insert a new item into the priority queue, we simply add it to the end of the heap and then bubble it up until it is in the correct position. For example, if we insert the item with priority 0, it would be added to the end of the heap and then bubbled up to the root position, resulting in the following min heap: 0/511/8141913. Overall, a priority queue is a useful data structure for storing and organizing items with associated priorities in a way that allows for efficient retrieval of the item with the highest priority. It is often implemented using a heap data structure, which allows for efficient insertion and removal of items. Overall, a priority queue is a useful data structure for storing and organizing items with associated priorities in a way that allows for efficient retrieval of the item with the highest priority. It is often implemented using a heap data structure, which allows for efficient insertion and removal of items from the priority queue. The backtracking method is a general algorithm for finding solutions to problems that involve making decisions based on partial information. It is often used for solving problems in which a solution can be constructed by making a sequence of choices, each of which may lead to multiple possibilities. The backtracking method works by systematically exploring all the possible choices and their consequences, until a solution is found or it is determined that no solution exists. At each step in the process, the algorithm considers all the possible choices and selects the one that seems most promising. If the chosen option leads to a dead end, the algorithm backtracks to the previous step and tries a different option. This process is repeated until a solution is found or all the possibilities have been explored. Here is an example of how the backtracking method can be used to solve the 8 queens problem, which is a classic problem in computer science. Function solve 8 queens, / create an empty 8x8 chessboard. Let board equals 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, board 0, 0 equals 1 / use the backtracking method to place the remaining queens if, solve 8 queens recursive, board, 0, 0, / if a solution was found, print the chessboard for, let I equals 0, I. I++, console.log, board I, else / if no solution was found, print a message console.log, no solution found, function solve 8 queens recursive, board, row. COL, / check if all the queens have been placed if, row equals 8, return true / try all the columns in the current row for, let I equals 0, I. I++, / check if the queen can be placed at position, row, I, if, can place queen, board, row, I, / place the queen at position, row. I, board row I equals 1 / recursively place the remaining queens if, solve 8 queens recursive, board, row plus 1, I, return true / if the current choice leads to a dead end.
It's not very good for this kind of thing. The text-to-speech, and also ChatGPT seems to be good, but I don't think I'm gonna learn that much by... The explanations are good, but yeah, I'm not gonna spend a bunch of time. And I'm not gonna do this one again because the backtracking method, because I'm already gonna put the uncream problem. But I think it's just too superficial, I think, maybe, to really get a good idea about these things. But I guess it's a nice introduction. Auxiliary space complexity I already knew about, so that description there wasn't very helpful. The other ones, I think I've seen them, but I didn't remember, especially this Prim's algorithm. And I didn't understand the explanation really well, so I'm probably gonna have to study that again at some point if I ever gonna use this. And I understand its explanation about backtracking method, but it's still not good enough to be able to really know how to code the algorithm. And I didn't spend enough time there to understand the algorithm that I was talking about, but that's fine. I think I will skip these ones as well, because I'm not that interested on them. I think, no, the last time I saw bubble sort, I think. Bubble sort and binary search. And I studied these algorithms as well, but I don't remember which one is which. But I know they are all for sorting arrays. But I don't think it's gonna be, it's not that interested in that. And I can also look it up anytime. But I guess I'm gonna study this, I'm gonna put this along with this input here, so it's probably gonna talk about the differences between them. I think this is a better input to give than this 4 here. Maybe I should put all of these in the same input as well. Oh, fuck. There's a typo here. Yeah, I'm not gonna redo this because it's gonna explain, so even though there's a typo here, it doesn't matter. Yeah, I don't think I'm gonna copy this. I was thinking about copying the Bellman fart. This looks incomplete, so maybe some other time. I think I'm gonna turn the texture speech and do this on the next one. There's already too many. It's gonna take too long. Yeah, so if it takes 1.5 hours for to do, oh, actually it's 2 of them in 1.5 hours. So it's actually the 11. It's gonna take 7 or 8 hours to do the rest. It's not that much actually. Okay, let's do this.
The n-queens problem is a classic problem in computer science that involves finding a way to place n-queens on a chessboard in such a way that no two queens are attacking each other. This means that no two queens can be in the same row, column, or diagonal on the chessboard. The subset sum problem is a well-known problem in computer science that involves finding a subset of a set of numbers that has a given sum. This problem is often studied in the context of data structures and algorithms because it can be solved using a variety of different algorithms and data structures. One common approach to solving the subset sum problem is to use dynamic programming, which involves breaking the problem down into smaller subproblems and then solving each of those subproblems recursively. Another approach is to use a brute force search algorithm, which involves trying all possible subsets of the given set of numbers until a subset with the desired sum is found. The Hamiltonian circuit problem is a problem in computer science that involves finding a Hamiltonian circuit in a graph. A Hamiltonian circuit is a cycle that passes through every vertex in the graph exactly once and then returns to the starting vertex. The problem of finding a Hamiltonian circuit is considered to be difficult, and there is no known efficient algorithm for solving it. In general, the best known algorithms for solving the Hamiltonian circuit problem have a time complexity that is exponential in the number of vertices in the graph. The traveling salesman person problem, TSP, is a classic problem in computer science that involves finding the shortest possible route that visits a given set of cities and returns to the starting city. The problem is called the traveling salesperson problem because it can be applied to a scenario in which a salesperson needs to visit a number of cities and wants to find the shortest possible route that allows them to visit all of the cities and return to their starting location. The traveling salesperson problem is considered to be difficult, and there is no known efficient algorithm for solving it. In general, the best known algorithms for solving the TSP have a time complexity that is exponential in the number of cities. Kruskal's algorithm is a well-known algorithm for finding the minimum spanning tree of a graph. The minimum spanning tree of a graph is a subset of the edges of the graph that form a tree and have the property that the sum of the weights of the edges in the tree is minimized. Kruskal's algorithm works by sorting the edges of the graph by weight, and then adding them to the minimum spanning tree in increasing order of weight. If adding a particular edge would create a cycle in the tree, the edge is discarded. This process is repeated until there are no more edges left to add, at which point the minimum spanning tree will have been found. Kruskal's algorithm is known for its simplicity and efficiency, and it is often used in network design and other applications. A non-minimum spanning tree is a spanning tree of a graph that does not have the property of having the minimum sum of edge weights among all spanning trees of the graph. In other words, a non-minimum spanning tree is a spanning tree of a graph that can be improved by replacing one or more of its edges with other edges from the graph, such that the sum of edge weights is reduced. A minimum spanning tree, on the other hand, is a spanning tree that has the property of having the minimum sum of edge weights among all spanning trees of the graph, and cannot be improved by replacing any of its edges with other edges from the graph. A disjoint set data structure, also known as a union-find data structure, is a data structure that tracks a set of elements partitioned into a number of disjoint, non-overlapping, subsets. It supports two main operations. Find, given an element, find the subset, or set, to which it belongs. Union, given two elements, merge the subsets, or sets, to which they belong into a single subset, or set. Disjoint set data structures are often used to implement Kruskal's algorithm for finding the minimum spanning tree of a graph, as well as other algorithms that involve partitioning a set of elements into disjoint subsets. They are known for their efficiency and simplicity, and are widely used in computer science. A queue is a linear data structure that is used to store data in a first in, first out, FIFO, manner. In other words, the first element that is added to the queue is also the first element to be removed from the queue. A circular queue is a type of queue in which the last element is connected to the first element, so that the queue can be treated as a circle. This allows for efficient insertion and deletion of elements at the beginning and end of the queue, as well as the use of a fixed size array to implement the queue. A priority queue is a type of queue that is used to store data in a way that allows for efficient retrieval of the highest priority element. In other words, when an element is added to the queue, it is assigned a priority, and the highest priority element is always the next element to be removed from the queue. A deq queue, pronounced deq, is a double-ended queue, which is a type of queue that allows for the insertion and deletion of elements at both the beginning and the end of the queue. This makes it possible to efficiently implement both stacks and queues using a single data structure. The main difference between these data structures is the way they are used and the operations they support. A queue is a simple linear data structure that only supports insertion at the end of the queue and removal from the beginning of the queue. A circular queue is similar to a queue, but it is implemented using a fixed size array and allows for efficient insertion and deletion at the beginning and end of the queue. A priority queue is a specialized queue that allows for efficient retrieval of the highest priority element. A deq queue is a double-ended queue that allows for efficient insertion and deletion of elements at both the beginning and the end of the queue. One similarity between these data structures is that they all store data in a specific order, and the order in which elements are added to and removed from the data structure determines the order in which they are stored and accessed. Another similarity is that they all support operations for inserting and removing elements, although the specific operations and the order in which they are performed may vary between different types of queues. A hash function is a mathematical function that is used to map data of arbitrary size to data of a fixed size. The output of a hash function is often called a hash value, message digest, digital fingerprint, or simply a hash. Hash functions are commonly used in computer science for a variety of purposes, such as data integrity, data indexing, data compression, and cryptography. A hash function has the following properties. It is deterministic, meaning that the same input will always produce the same output. It is easy to compute the hash value for any given input. It is difficult to determine the input given only the hash value, the preimage resistance property. It is difficult to find two different inputs that produce the same hash value, the collision resistance property. A good hash function should have a low collision rate, meaning that it should produce unique hash values for the vast majority of inputs. It should also be fast to compute and should have a reasonable amount of security against attacks that aim to find collisions or determine the input from the hash value. Yes, tree traversals in binary trees are equivalent to a depth-first search. In a depth-first search, the algorithm traverses the tree by exploring as far as possible down each branch before backtracking and exploring other branches. This is exactly the same way that a tree traversal algorithm would traverse a binary tree. In particular, the three most common types of tree traversals, pre-order, in-order, and post-order, can be seen as specific implementations of a depth-first search algorithm. Heap sort is a comparison-based sorting algorithm that uses a binary heap data structure to sort a given array of elements. A binary heap is a complete binary tree, which means that it is a binary tree in which all levels are completely filled, except possibly the last level, which is filled from left to right. To perform heap sort, the algorithm first constructs a binary heap from the given array of elements. This is done by starting with an empty binary heap and then successively adding each element of the array to the heap while maintaining the heap property, which states that the value of each node in the heap must be greater than or equal to the values of its children, for a max heap, or less than or equal to the values of its children, for a min heap. Once the binary heap has been constructed, the heap sort algorithm removes the top element from the heap, which is always the largest or smallest element, depending on whether the heap is a max heap or a min heap, and places it at the end of the sorted array. This process is repeated until the heap is empty, at which point the entire array will be sorted in ascending or descending order, depending on the type of heap used. Heap sort has a time complexity of O n log n, which makes it one of the more efficient sorting algorithms. It has the advantage of being stable, i.e., preserving the relative order of elements with the same value, and it can be performed in place, i.e., without using additional storage space. However, it is not as efficient as some other sorting algorithms, such as quicksort, in the average case. What is the best algorithm for partially sorted array? Rightward arrow quicksort, insertion sort, selection sort, merge sort. The best algorithm for partially sorted array is probably quicksort. Quicksort is a comparison-based sorting algorithm that uses a divide-and-conquer approach to sort a given array of elements. It has an average time complexity of O n log n, which makes it one of the most efficient sorting algorithms. Quicksort works by partitioning the array into two subarrays around a pivot element, such that all elements in the left subarray are less than or equal to the pivot, and all elements in the right subarray are greater than or equal to the pivot. This partitioning process is then repeated recursively on the left and right subarrays until the array is fully sorted. One advantage of quicksort is that it can adapt to the specific ordering of the input array. If the input array is already partially sorted, quicksort can take advantage of this by choosing pivot elements that are close to the median value of the array, which reduces the time complexity of the algorithm. This makes quicksort particularly well suited for partially sorted arrays. In contrast, insertion sort, selection sort, and merge sort are all O n-2 algorithms, which means they have a higher time complexity and are less efficient than quicksort on partially sorted arrays. Insertion sort and selection sort are both simple, in-place sorting algorithms that are easy to implement, but they have poor performance on large or partially sorted arrays. Merge sort is a divide-and-conquer sorting algorithm that has a time complexity of O n log n in the best and average cases, but it requires additional space to perform the sorting, which makes it less efficient than quicksort on partially sorted arrays. The Bellman-Ford algorithm is a single source shortest paths algorithm that can be used to find the shortest path from a given source vertex to all other vertices in a weighted graph. The algorithm is named after its inventors, Richard Bellman and Lester Ford, Jr., who published it in 1958. Here is an example of the Bellman-Ford algorithm implemented in pseudocode. / initialize the distance from the source vertex to all other vertices as infinity for each vertex v in the graph. If v is not the source vertex, dist v equals infinity else. Dist v equals 0 / repeat the following steps for v. 1 iterations for I equals 1 to v. 1 / relax all edges for each edge, u, v, in the graph. If dist v distu plus weight, u, v. Dist v equals distu plus weight, u, v, / check for negative weight cycles for each edge, u, v, in the graph. If dist v distu plus weight, u, v / the graph contains a negative weight cycle. In this code, dist v represents the distance from the source vertex to vertex v. V is the number of vertices in the graph, and weight, u, v, is the weight of the edge from vertex u to vertex v. The algorithm first initializes the distances from the source vertex to all other vertices as infinity, except for the source vertex itself, which has a distance of 0. It then repeats the following steps for v. 1 iterations. Relax all edges in the graph. This means that for each edge, u, v, in the graph, if the distance from the source vertex to v is greater than the distance from the source vertex to u plus the weight of the edge, u, v, the distance to v is updated to the new, shorter distance. Check for negative weight cycles. After all edges have been relaxed v, 1 times, the algorithm checks for any edges that can be relaxed further. If such an edge is found, the graph contains a negative weight cycle, and the algorithm terminates. The Bellman-Ford algorithm has a time complexity of O, v, which makes it slower than other single-source shortest paths algorithms, such as Dijkstra's algorithm. However, it has the advantage of being able to handle graphs with negative weight edges, which Dijkstra's algorithm cannot do. What is the best data structure for searching word in dictionaries? Rightward arrow BST, linked list, tree, balinked BST. The best data structure for searching words in dictionaries is probably a tree, pronounced try. A tree, also known as a digital tree or prefix tree, is a tree-like data structure that is used to store an associative array where the keys are sequences, usually strings. Each node in a tree represents a single character in a key, and the path from the root to a particular node forms a sequence of characters that represents a prefix of a key. The main advantage of using a tree for searching words in dictionaries is that it allows for efficient prefix matching, which is a common operation in dictionary search applications. For example, if the user is typing in a word and the dictionary contains a large number of words that start with the same prefix, a tree can be used to quickly find all of the words that match the prefix and present them to the user in real time. In contrast, a binary search tree, BST, is a data structure that is well suited for searching for individual words in a dictionary, but it does not support efficient prefix matching. A linked list is a linear data structure that is not well suited for searching operations, and a balanced binary search tree, BBST, is a data structure that is similar to a BST but has the added constraint of maintaining a balanced tree, which makes it less efficient for dictionary search applications. A balanced binary tree is a type of binary tree that is designed to maintain a specific balanced property, such as the height or the maximum number of nodes at any given depth. There are several different types of balanced binary trees, each with its own specific balanced property and set of operations for maintaining that property. Some examples of balanced binary trees include AVL trees, red-black trees, splay trees, and B trees. An AVL tree is a self-balancing binary search tree in which the height of the left and right subtrees of every node differ by at most 1. AVL trees maintain their balanced property by performing rotations on the tree when necessary. A red-black tree is a self-balancing binary search tree in which each node is either red or black. Red-black trees maintain their balanced property by enforcing certain constraints on the colors of the nodes, such as the requirement that no 2 consecutive nodes can be red. A splay tree is a self-balancing binary search tree in which the tree is rearranged based on the history of accesses to its elements. Splay trees maintain their balanced property by performing splaying operations on the tree, which move recently accessed elements closer to the root of the tree. A B tree is a self-balancing tree data structure that is commonly used for file systems and other applications that require efficient search, insertion, and deletion of elements. B trees maintain their balanced property by keeping the number of keys in each node within a certain range, and by allowing nodes to have more than 2 children. Balanced binary trees are designed to provide efficient search, insertion, and deletion operations. while at the same time maintaining a balanced property that ensures the tree remains relatively balanced, even after many operations have been performed on it. This makes them well suited for applications that require frequent access to large amounts of data, such as file systems and databases. In contrast, an ordered linear search is a simple search algorithm that uses a linear data structure, such as an array or a linked list, to store the data. In an ordered linear search, the data is assumed to be already sorted in ascending or descending order. And the algorithm searches for a particular element by comparing it to each element in the data structure in turn, until it is found or the end of the data structure is reached. Ordered linear search is simple and easy to implement, but it has a time complexity of O(n), which means it is not very efficient for large datasets. In contrast, balanced binary trees are much more efficient, with time complexities of O log n for most operations. This makes balanced binary trees a better choice for applications that require fast search, insertion, and deletion operations on large datasets. There are several different ways to traverse a tree data structure, each of which has its own specific characteristics and use cases. The four most common types of tree traversals are pre-order traversal, post-order traversal, level order traversal, and in-order traversal. Pre-order traversal is a type of tree traversal in which the current node is visited before its children. This means that the root node is always the first node to be visited, followed by the left subtree of the root, then the right subtree of the root. Pre-order traversal is often used to create a copy of a tree or to perform some operation on the nodes of a tree in a specific order. Post-order traversal is a type of tree traversal in which the current node is visited after its children. This means that the left subtree of the root is visited first, followed by the right subtree of the root, and then the root node itself. Post-order traversal is often used to delete a tree or to perform some operation on the nodes of a tree in a specific order. Level order traversal is a type of tree traversal in which the nodes of the tree are visited level by level, from left to right. This means that all the nodes at the first level of the tree are visited first, followed by all the nodes at the second level of the tree, and so on. Level order traversal is often used to perform some operation on all the nodes of a tree in a specific order. In-order traversal is a type of tree traversal in which the current node is visited between its children. This means that the left subtree of the root is visited first, followed by the root node itself, and then the right subtree of the root. In-order traversal is often used to perform some operation on the nodes of a binary search tree in a specific order. Each of these tree traversal algorithms has its own specific use cases and characteristics. For example, pre-order traversal is often used to create a copy of a tree or to perform some operation on the nodes of a tree in a specific order. Post-order traversal is often used to delete a tree or to perform some operation on the nodes of a tree in a specific order. Level order traversal is often used to perform some operation on all the nodes of a tree in a specific order. In-order traversal is often used to perform some operation on the nodes of a binary search tree in a specific order. Tree traversal algorithms are an important part of many algorithms and data structures that operate on trees, such as binary search trees and other tree-like data structures. They provide a way to visit the nodes of a tree in a specific order, which can be useful for many different operations, such as searching for a particular element in a tree, deleting a tree, or performing some operation on the nodes of a tree. Free research preview: ChatGPT is optimized for dialogue.
Yeah, this is a very nice explanation, but I'm not gonna remember this. Maybe I should write this one down because I thought it was really good. I'm not sure if it's right or wrong, but it seems to be right. Oh, I forgot to put this on red. So this was probably a question, which algorithm to use for a minimum spanning tree of graph. And then the options were these ones. I guess it's the cruise call that is gonna say it's the answer. Not sure. It's not giving me very detailed answers, and I don't feel like asking for detailed answers because, like I said, it's probably not the best way to learn this. It's just a good way to get a superficial learning from these topics. And I'm doing them because they are part of the files that I have here. I think this style with ChatGPT is probably better for things like React or the other ones that I did so far.
A circular linked list is a type of linked list in which the last node points to the first node, forming a cycle. This allows for efficient insertion and deletion of elements, as the list can be traversed in either direction. Unlike a regular linked list, a circular linked list does not have a null value to indicate the end of the list, so the number of elements in the list must be tracked explicitly. In the quicksort algorithm, the partition operation is used to divide the input list into two smaller sublists. This is done by selecting a pivot element from the list and arranging the other elements in the list into two groups, those that are less than the pivot, and those that are greater than the pivot. The pivot is then placed between these two groups, resulting in two sublists that can be sorted individually using the same quicksort algorithm. This process is repeated until the list is fully sorted. The partition operation is crucial to the efficiency of the quicksort algorithm, as it determines the split between the two sublists and therefore affects the overall runtime of the algorithm. Minimum spanning tree of graph rightward arrow Boruvka's algorithm, Prim-S algorithm, Kruskal's algorithm, Bell-Manifold algorithm. A minimum spanning tree, MST, of a graph is a subset of the edges of the graph that connects all of the vertices together, without any cycles and with the minimum possible total edge weight. There are several algorithms that can be used to find the minimum spanning tree of a graph, including Boruvka's algorithm, Prim's algorithm, and Kruskal's algorithm. Boruvka's algorithm is a greedy algorithm that repeatedly finds the minimum spanning tree of the connected components of the graph, until all of the vertices are connected in a single minimum spanning tree. Prim's algorithm is a greedy algorithm that starts with a single vertex and adds the minimum weight edge to the growing minimum spanning tree at each step. Kruskal's algorithm is a greedy algorithm that sorts the edges of the graph by weight and adds them to the minimum spanning tree in ascending order, as long as doing so does not create a cycle. The Bellman-Ford algorithm is a more general algorithm for finding the shortest path between two vertices in a graph. But it can also be used to find the minimum spanning tree by setting the source vertex to be the starting point and the target vertex to be the endpoint of the spanning tree. The Floyd-Warshall algorithm is an algorithm for finding the shortest path between all pairs of vertices in a weighted graph. It is a dynamic programming algorithm that is capable of solving the all pairs shortest path problem in time O, n-3, where n is the number of vertices in the graph. The algorithm works by iteratively updating the distance matrix of the graph, which stores the shortest known distance between each pair of vertices. At each iteration, the algorithm considers all possible paths between the vertices and updates the distance matrix with the minimum of the current distance and the distance of the new path. This process is repeated until the distance matrix is fully updated and the shortest paths between all pairs of vertices are known. Dijkstra's algorithm is an algorithm for finding the shortest path between a source vertex and all other vertices in a weighted graph. It is a greedy algorithm that uses a priority queue to efficiently explore the vertices of the graph and determine the shortest path to each one. The algorithm starts by adding the source vertex to the priority queue and assigning a distance of 0 to it. At each step, the algorithm removes the vertex with the smallest known distance from the priority queue and relaxes its edges, which means updating the distances of its neighboring vertices based on the new shortest path to the current vertex. This process is repeated until all vertices have been visited and the shortest path to each one is known. Unlike the Floyd-Warshall algorithm, which can be used to find the shortest path between all pairs of vertices, Dijkstra's algorithm is only applicable to graphs with non-negative edge weights. In-place merge sort is a variation of the merge sort algorithm that uses only a constant amount of additional memory, making it well suited for sorting large lists that cannot fit entirely in main memory. To do this, the algorithm uses an in-place merging technique, which performs the merge operation by swapping elements in the input list rather than using a separate output list. This allows the algorithm to sort the list without allocating any additional memory for the output. Despite the savings in memory, in-place merge sort has the same time complexity as regular merge sort, which is O, n asterisk log, n, for the best, average, and worst cases. Free research.
I'm not sure why I wrote down this one. Yeah, I'm just gonna do this. Right back. I don't think I'm gonna take any breaks. I'm gonna listen to this one, and then I think I will try to do another one and then stop directly after this one.
Cluster IP is a type of service in Kubernetes that exposes a set of pods to other objects in the cluster. It is the default service type and is only accessible within the cluster. Node port is a type of service in Kubernetes that exposes a specific port on each node in the cluster. This allows external traffic to access the service by sending requests to the node IP and port. Load balancer is a type of service in Kubernetes that exposes a service to external traffic. It typically uses an external load balancer provided by a cloud provider to distribute incoming traffic among the pods of the service. External name is a type of service in Kubernetes that maps a service to a DNS name instead of an IP address. This allows the service to be accessed using the DNS name, without the need to know the underlying IP address. The memory swap flag is used to specify the total amount of memory and swap that a container is allowed to use. It is used in conjunction with the memory flag, which specifies the amount of memory that the container is allowed to use. For example, if you want to limit a container to use no more than 512 megabytes of memory and 1 GB of swap, you could use the following command. $docker run memory 512M memory swap 1 G my container. This would ensure that the container is not allowed to use more than 512 megabytes of memory and 1 GB of swap, even if the host machine has more available. It's important to note that setting a memory swap value greater than the memory value can allow the container to use more memory than it is allowed, so it is recommended to set the memory swap value to the same or lower than the memory value. Amazon Web Services, AWS, provides a service called auto-scaling that allows users to automatically scale their Amazon Elastic Compute Cloud, EC2, instances in response to changing demand. This can help users ensure that they have the right amount of EC2 instances available to handle their workloads, while also minimizing costs by only using the necessary number of instances. Auto-scaling can automatically increase or decrease the number of EC2 instances based on predefined policies and metrics. For example, users can set a policy to automatically scale their EC2 instances up when the average CPU utilization of the instances exceeds a certain threshold, and to scale the instances down when the utilization falls below a certain threshold. Auto-scaling also provides features to help ensure high availability of applications, such as the ability to automatically replace faulty instances and to distribute instances across multiple availability zones. This can help users ensure that their applications remain available and performant, even in the face of hardware failures or other issues. NoSQL and SQL are two different types of databases. SQL, or Structured Query Language, is a programming language that is used to manage and query relational databases. SQL databases are organized into tables, which consist of rows and columns. Each row represents a record, and each column represents a specific attribute of the record. SQL databases are well suited for applications that require complex queries and transactions, and they often provide features such as referential integrity and support for primary and foreign keys. NoSQL, on the other hand, stands for not only SQL. It is a type of database that does not use the traditional SQL query language, and is typically designed to support scalable, distributed, and high-performance applications. NoSQL databases are often used for large-scale applications that require flexible and scalable data storage, such as web and mobile applications, real-time analytics, and Internet of Things, IoT, applications. Unlike SQL databases, NoSQL databases do not have a fixed schema, and can store data in a variety of formats, such as key-value pairs, documents, graphs, or columns. In general, SQL databases are well suited for applications that require complex queries, transactions, and strict consistency, while NoSQL databases are better suited for applications that require high performance, scalability, and flexibility. A regular expression, or regex, is a sequence of characters that is used to match patterns in strings. To find the
I
time.
just thought about something that SQL is the masculine and NoSQL is the feminine, because it has more flexibility, more potential, and then SQL is more rigid and more fixed. So is the two sides of the symmetry. And I wonder if anyone has invented a method that has both of them at the same time. It's probably the next evolution. Maybe that's crypto or something like that, but I don't know.
To find the time in a string, you can use a regex pattern that matches the time format you are looking for. For example, if you are looking for times in the 24-hour format, e.g. 1730 or 23:59, you could use the following regex pattern. 01, 0 to 9 to 0 to 3 0 to 5 0 to 9. This pattern will match any string that contains a time in the 24-hour format, with 1 or 2 digits for the hour and 2 digits for the minutes. If you are looking for times in the 12-hour format, e.g. 5:30 p.m. or 11:59 a.m., you could use the following regex pattern. 10 to 20, 1 to 90 to 50 to 9 \s*, am p.m. This pattern will match any string that contains a time in the 12-hour format, with 1 or 2 digits for the hour, 2 digits for the minutes, and am or pm for the time of day. It's important to note that these regex patterns are just examples, and may not match all possible time formats. You may need to modify the patterns to match the specific time format you are looking for. To share contents within containers in a pod, you can use a shared volume in Kubernetes. A shared volume allows multiple containers in a pod to access the same data stored on the volume. There are several types of shared volumes available in Kubernetes, including empty dir, host path, and persistent volume claim. Empty dir, this type of volume is created when a pod is assigned to a node, and exists as long as the pod is running on that node. It is useful for temporary storage of data that does not need to be preserved after the pod is terminated. Host path, this type of volume mounts a file or directory from the host node into the pod. It allows containers in the pod to access data on the host node. Persistent volume claim. This type of volume is used to access persistent storage provided by a persistent volume in Kubernetes. It allows containers in the pod to access the data stored on the persistent volume, even if the pod is rescheduled to a different node. To use a shared volume in a pod, you can specify the volume type and other relevant details in the pod's YAML configuration file. For example, the following configuration file specifies an empty dir volume named myVolume that can be accessed by containers in the pod. API version, v1 kind, pod metadata, name, mypod spec, containers, name, my container image, my image volume mounts, name, my volume mount. In this example, the containers in the pod can access the contents of the myVolume volume at the path/path/to/volume. The contents of the volume will be deleted when the pod is terminated. Classic load balancer and application load balancer are two types of load balancers provided by Amazon Web Services, AWS. Classic load balancer is a legacy load balancer that was introduced by AWS in 2009. It is a layer 4 load balancer, which means it routes traffic based on network level information, such as the source and destination IP addresses and port numbers. Classic load balancer supports two types of load balancing: TCP load balancing, which is used for layer 4 load balancing of TCP traffic, and SSL/TLS load balancing, which is used for secure load balancing of HTTPS traffic. Application load balancer is a more recent load balancer that was introduced by AWS in 2016. It is a layer 7 load balancer, which means it routes traffic based on application level information, such as the HTTP and HTTPS headers, cookies, and the URL path. Application load balancer also supports content-based routing, which allows users to route traffic to different back-end applications based on the content of the request. It also supports WebSockets and HTTP/2, which allows for more efficient communication between clients and servers. In general, classic load balancer is well suited for simple load balancing scenarios, while application load balancer is better suited for more complex, application-level load balancing. In Kubernetes, a namespace is a logical boundary for resources in the cluster. It is used to group related resources, and to provide a unique scope for resource names. Each Kubernetes resource, such as a pod, service, or deployment, can be associated with a namespace. This allows users to organize their resources into logical groups, and to avoid naming conflicts between resources in different namespaces. For example, if you have two different applications running in the same Kubernetes cluster, you could create two separate namespaces for each application. This would allow you to deploy the resources for each application, such as pods, services, and deployments, into the corresponding namespace, without worrying about naming conflicts with the other application. To associate a resource with a namespace, you can specify the namespace in the resource's YAML configuration file. For example, the following YAML configuration file defines a pod that belongs to the namespace. API version, v1 kind. In this example, the pod named mypod will be created in the namespace. This means that the pod will be accessible only within that namespace, and will not conflict with any other resources in other namespaces with the same name. In Unix-like operating systems, the /bin and /bin directories are used to store binary executables, which are programs that can be run by the operating system. The /bin directory is the primary directory for storing binary executables that are used by both the system and users. It typically contains executables that are essential for the system to function, such as the ls and cd commands, as well as basic utilities and shell scripts. The /bin directory, on the other hand, is used to store binary executables that are used for system administration tasks. These executables are typically only used by system administrators or other users with special privileges, and are not necessary for the normal operation of the system. Examples of executables in /bin include reboot, fdisk, and ifconfig. In general, the /bin directory contains executables that are essential for the system to function, while the /bin directory contains executables that are used for system administration tasks. In the context of container technology, a container is a lightweight, standalone, and executable package of software that includes everything needed to run an application, including the code, libraries, dependencies, and runtime. Containers are isolated from each other and from the host operating system, which allows them to be portable and consistent across different environments. Kubernetes is an open-source platform for managing and orchestrating containerized applications. It provides a number of abstractions, such as pods, services, and deployments, that make it easier to deploy, scale, and manage applications that are made up of multiple containers. Controllers are components in Kubernetes that are responsible for maintaining the desired state of the system. For example, a deployment controller is responsible for ensuring that the correct number of replicas of a pod are running at any given time. A service is an abstraction in Kubernetes that represents a group of pods that provide the same functionality. A service provides a stable endpoint for clients to access the pods, and can load balance traffic among the pods. This allows clients to access the pods without knowing their specific IP addresses or locations. In summary, containers are standalone packages of software that can run on any platform. Kubernetes is a platform for managing and orchestrating containerized applications. Controllers are components that maintain the desired state of the system, and services are abstractions that provide a stable endpoint for accessing groups of pods. In Kubernetes, a daemon set is a type of workload that ensures that a specific number of copies of a pod are running on each node in the cluster. This is useful for running certain types of workloads, such as logging agents or monitoring agents, that need to run on every node in the cluster. A daemon set is defined by a daemon set object in Kubernetes. The object specifies the pod template that should be used to create the pods, as well as the desired number of copies of the pod that should be running on each node. When a daemon set is created, Kubernetes ensures that the specified number of pods are running on each node in the cluster. If a new node is added to the cluster, Kubernetes will automatically create the necessary number of pods on the new node. If a node is removed from the cluster, Kubernetes will automatically terminate the pods running on the node. This ensures that the desired number of pods are always running on each node in the cluster. In summary, a daemon set in Kubernetes is a type of workload that ensures that a specific number of copies of a pod are running on each node in the cluster, and automatically manages the pods to maintain this desired state. To deal with a significant amount of traffic for AWS applications and databases, you can use a number of different strategies and services provided by Amazon Web Services, AWS. One approach is to use horizontal scaling, which involves increasing the number of instances or replicas of your application or database to handle more traffic. This can be done manually, by manually launching additional instances or replicas, or automatically using services such as Amazon Elastic Container Service, ECS, or Amazon Elastic Kubernetes Service, EKS, to scale the number of instances or replicas based on predefined policies and metrics. Another approach is to use caching to reduce the load on your application or database. This involves storing frequently accessed data in a cache, such as Amazon Elastic Cake, so that it can be quickly retrieved without hitting the underlying application or database. This can help reduce the number of requests that need to be handled by the application or database, and improve the overall performance of your system. You can also use load balancing to distribute incoming traffic among multiple instances or replicas of your application or database. This can help ensure that your application or database remains available and performant, even under heavy load. AWS provides a number of load balancing services, such as Amazon Elastic Load Balancer, ELB, and Amazon Application Load Balancer, ALB, which can be used to distribute incoming traffic among multiple instances or replicas. In summary, to deal with a significant amount of traffic for AWS applications and databases, you can use horizontal scaling, caching, and load balancing to increase the capacity and performance of your system. To deploy an application on an Amazon Elastic Compute Cloud, EC2, instance that writes data to an Amazon DynamoDB table, you can use the following steps. Create an EC2 instance. First, create an EC2 instance in the same AWS region as your DynamoDB table. You can choose the type and size of the instance based on the performance and resource requirements of your application. Install the necessary dependencies. Next, install any necessary dependencies, such as the AWS SDK or other libraries, on the EC2 instance. This will allow your application to access the DynamoDB API and interact with the table. Configure the AWS credentials. After installing the dependencies, configure the AWS credentials for the EC2 instance. This will allow your application to authenticate with the AWS services and access the DynamoDB table. Deploy your application. Finally, deploy your application on the EC2 instance. Make sure to configure the application to use the AWS credentials and the correct DynamoDB table name. Test the application. Once your application is deployed, test it to ensure that it is able to write data to the DynamoDB table. You can use the AWS Management Console or the DynamoDB API to verify that the data is being written to the table correctly. In summary, to deploy an application on an EC2 instance that writes data to a DynamoDB table, you can create an EC2 instance, install the necessary dependencies, configure the AWS credentials, deploy your application, and test it to ensure that it is working correctly. The relationship between network IDs and binary bits is that the network ID is used to identify a specific network in a network address, and the binary bits are used to represent the network ID in a binary format. In networking, a network address is a unique identifier that is assigned to a network or a group of devices on a network. The network address consists of two parts, the network ID, which identifies the network, and the host ID, which identifies the specific device on the network. The network ID is typically represented in binary format, using a specific number of bits, depending on the network's addressing scheme. For example, in the IPv4 addressing scheme, a network address is typically represented using 32 bits, with the first 8 bits representing the network ID and the remaining 24 bits representing the host ID. This means that there are 256 possible network IDs in the IPv4 addressing scheme, which are represented using 8 binary bits. 28 equals 256. In summary, the network ID is used to identify a specific network in a network address, and the binary bits are used to represent the network ID in a binary format. The number of binary bits used to represent the network ID depends on the network's addressing scheme. The network equals host option is used to run a container in the host's network namespace. This means that the container will share the network stack and network interfaces of the host, and will be able to directly access the host's network resources. Running a container with the network equals host option can be useful in certain scenarios, such as when the container needs to bind to a specific port on the host, or when the container needs to access the host's network interfaces directly. However, it is generally considered best practice to use a separate network namespace for containers, to isolate them from the host and from other containers. To run a container with the network equals host option, you can use the docker run command with the network flag, as shown in the following example. Docker run network equals host myimage. In this example, the container will be run in the host's network namespace, and will be able to access the host's network resources directly. It's important to note that running a container with the network equals host option can have security implications, as the container will have direct access to the host's network resources. It's recommended to use this option only when it is necessary, and to carefully evaluate the security implications before using it. To program additional authentication logic besides the available authenticator modules, you can create a custom authentication module or plugin. This involves writing code that implements the necessary authentication logic, and integrating the module or plugin with the authentication system. The exact steps for creating a custom authentication module or plugin will vary depending on the specific authentication system you are using. In general, the steps might include: identify the authentication system and the available APIs or interfaces for creating custom authentication modules or plugins. Review the existing authenticator modules or plugins to understand how they are implemented and how they integrate with the authentication system. Write the code for the custom authentication module or plugin, implementing the necessary authentication logic. This might involve defining custom authentication methods, implementing authentication checks, or integrating with external authentication systems. Test the custom authentication module or plugin to ensure that it is working correctly and meets the requirements. Integrate the custom authentication module or plugin with the authentication system, using the available APIs or interfaces. This might involve configuring the authentication system to use the custom module or plugin, and setting any necessary parameters or options. Test the integration of the custom authentication module or plugin with the authentication system, to ensure that it is working correctly and that the additional authentication logic is being applied as expected. In summary, to program additional authentication logic besides the available authenticator modules, you can create a custom authentication module or plugin. Implement the necessary authentication logic, and integrate it with the authentication system. To remove all the rules in an iptables table, you can use the iptables command with the F or flush option. This option allows you to remove all the rules in the specified table, without affecting the default policies or the other tables. For example, to remove all the rules in the filter table, you can use the following command. iptables tfilter F. This command will remove all the rules in the filter table, but will not change the default policies or the other tables. It's important to note that using the F or flush option will remove all the rules in the specified table, including any custom rules you have added. This can have unintended consequences, such as breaking existing connections or blocking access to certain services. It's recommended to use this option only when you are sure that you want to remove all the rules in the table. In summary, to remove all the rules in an iptables table, you can use the iptables command with the F or flush option, specifying the name of the table you want to flush. This will remove all the rules in the specified table, without affecting the default policies or the other tables. Free research.
Yeah, I think I'll just finish this file because I noticed that it's already getting harder to focus, and it's probably gonna be... I think what I'm gonna do is stop the stream and then take a break. I'm gonna play some poker, I think. And then after I take some break, then I'm gonna do one more file off stream, I think. Maybe 1 or 2 files off stream. It's probably gonna be easier to focus, and then I'll come back to this tomorrow. And tomorrow, I think, yeah, I'm gonna have to think about this. Because I also have to structure the other videos, but I want to finish this stuff here. So I think I'll do... Let me just put this. I will structure the other video first, and then I'll continue to do this, depending on how long it takes to structure the videos and then film them off stream. Actually, I'm not gonna film the introduction. I'm just gonna film the... Just gonna record the next video. I'm gonna structure the next video and then record it off stream. And then depending on how long that takes, then I come back and continue to do this stuff. But yeah, I don't know. Ideally, I'll be able to finish this by tomorrow, because then I have extra time while ChatGPT is still free. I have extra time to study other things that I'm curious about, besides all of this stuff. And there's 2 main pathways that I wanna explore. One is the Python. Actually, there's several different pathways, but I think probably one of the most useful ones is gonna be the Python compiler, Python interpreter, understanding the source code that I tested out, and it seems that it has some nice outputs. And the other stuff that I wanna explore is stuff to do with synapses and learning more efficiently, and biology, the biochemistry of the body. It's also seeming interesting to use ChatGPT for that. But that one is less, that has less to do with what I'm doing. And then obviously besides that, there's countless applications or countless things that I can think about the blockchain, MEV, zero knowledge proof, all of this stuff. So I'm gonna have to spend some time thinking once I'm finished with these files on which direction I should go, but I'll probably go with Python first, Python interpreter. And yeah, I'm probably gonna use it in a way that it helps me create the videos or find answers to the questions that I had. So use it in general to study so I can be more prepared to create videos for the other channel. That's probably what I'm gonna do. Oh, another interesting thing that I just thought about is maybe that's what I should do actually. The first thing that I should do is use this thing to help me build structure the blog that I'm converting from React to Next.js, and then that I want to put to database. Yeah, that's probably what I should do actually. It's probably the best application because it's more direct to what I'm doing now. And to make videos about the Python interpreter is gonna take a lot of time because there's a bunch of other videos that I can do before that. Yeah. So I'm probably gonna use it to help me finish building the blog and incorporate Web3 into it. And also maybe use it to build smart contracts or build other pages, landing pages. Use it to help me build the emails for email marketing, things like that. Should be really interesting. If there's enough time, obviously. Don't know when they're gonna start charging for that. Maybe they start tomorrow.
A role and a cluster role are both used to grant access to certain resources in the cluster. The main difference between the two is that a role is only valid within a certain namespace, while a cluster role is valid cluster-wide and can be used to grant access to resources in any namespace. To save open files and flush the system cache on a Linux system, you can use the sync command. This will write any unsaved data to disk and clear the system cache. You can run the sync command by opening a terminal and typing sync. Press enter to run the command. You should see a message indicating that the system cache has been flushed. It's important to note that the sync command only flushes the system cache, it does not perform any other system maintenance tasks. To perform other maintenance tasks, you may need to use other commands or tools. For example, you can use the fsck command to check and repair file system errors, or the apt-get command to update and upgrade installed packages. It's always a good idea to regularly perform system maintenance tasks to keep your system running smoothly and efficiently. The /tmp directory is typically only writable by the root user, so a non-root user would not be able to delete files from this directory directly. However, a non-root user can use the sudo command to execute a command as the root user. For example, to delete a file from the /tmp directory, a non-root user could use the following command: sudo rm/tmp/mfile. This would delete the file mfile from the /tmp directory. The user would be prompted to enter their password to confirm their identity and authorize the sudo command. It's important to use the sudo command carefully, as it allows a user to execute commands with the full privileges of the root user. This can be dangerous if the user is not careful, as it allows them to potentially make changes to the system that could cause serious problems. For this reason, it's generally best to avoid using the sudo command unless absolutely necessary, and to make sure that users who do use it are trained on how to use it safely and responsibly. If you have made changes to your php.ini file and want to restart the Apache web server to apply the changes, you can use the service command to do so. Assuming that the Apache web server is installed and running on your system, you can restart it by using the following command: sudo service apache 2 restart. This will stop the Apache web server, apply the changes from the php.ini file, and then start the web server again. You should see a message indicating that the Apache web server has been restarted. If you are using a different web server, the exact command to restart it may be different. For example, on a system that uses the Nginx web server, the command would be sudo service nginx restart. You can use the service command to manage other services on your system as well. For example, you can use it to stop, start, or restart services like the MySQL database server or the SSH service. To see a list of all available services, you can use the service status all command. DevOps.
Another thing that popped up in my mind now is that I should probably also go over the file that I have with the GPT information. But I think that's for later because I want to take advantage of the chat thing while it's still free. So probably what I'm going to do is use it a bunch to put more and more information on this file of the inputs that I get. And then later on I can go over this file as well and then do the same thing that I'm doing for the other files, but searching on Google instead and on multiple different sources, watching videos about these things. So it should also be interesting. And I think I'm gonna finish this after. Yeah, the next video that I'm gonna do is gonna be really easy, which is about functions. But then right after that, I'm gonna do a video about the methods. And that video I think is gonna be really hard to make. It's gonna take a lot of time because what I'm planning to do is explain what methods are, and then to go over all the methods, not all the methods, but I will try to focus on the 20-80-20 rule, focus on the ones that are used most often, and then do a hierarchy of maybe 5 of them for each. So 5 methods for strings, 5 methods for arrays, 5 methods for objects, or even more. And then to do the video showing side by side the method in Python and the method in JavaScript, and explain each one of them, and do so the whole video is going to be about that. I think that's going to be really good. but it's gonna take a lot of work and it's gonna take a lot of time to do it. So I think I have to finish this as fast as possible so I can finish before working on that video so I have more time. So I'm definitely gonna work on finishing this right after I work on the next video, I think.
DevOps technique for automated testing environment, fast deployment processes, and sufficient telemetry. There are several DevOps techniques that can be used for automated testing, fast deployment processes, and sufficient telemetry. Some examples of these techniques include continuous integration and continuous delivery, CI/CD. This is a set of practices that automate the process of building, testing, and deploying software. With CI/CD, developers can commit code changes to a shared repository, and a continuous integration server will automatically build, test, and deploy the changes. This allows for fast and frequent deployments, and ensures that new code is always tested before it is released. Infrastructure as code. This is a practice that treats infrastructure, e.g. servers, networks, and storage, as if it were code. This allows infrastructure to be managed, versioned, and automated in the same way as application code. This makes it easier to deploy, scale, and manage infrastructure, and can help ensure that the right configuration is always in place for testing and production environments. Monitoring and logging. Monitoring and logging are essential for gathering telemetry data and keeping track of what is happening in your environment. By using monitoring and logging tools, you can collect data on system performance, application behavior, and other important metrics. This data can be used to identify and troubleshoot problems, and to improve the overall performance and reliability of your systems. By using these and other DevOps techniques, you can create an automated testing environment that is fast, efficient, and capable of providing the telemetry data you need to make informed decisions about your systems. Free research.
Yeah, so I think I'm done for today. I'm probably gonna come back tomorrow. Like almost 100% sure. Maybe 80% sure. And I'll work on the function video first, then go record the video and come back and continue to do this stuff here because I think it's not gonna take a long time to do the function video, hopefully, unless I'm forgetting about things, which is possible. And then I'm gonna try to do at least 2 of these right after I finish this stream. Not right after, I'm gonna take a break, play poker, and then do them later on. So hopefully I can do 2 more off stream. So yeah.